Picture this: a galaxy unlike any other, spinning in the depths of space with a perfect ring of stars, so precise it looks almost artificial. This isn't science fiction. It's a real cosmic marvel known as a ring galaxy, one of the universe's most enigmatic structures. And what's even stranger, these celestial rings are hiding secrets that defy everything we thought we knew about how galaxies form and evolve. From ghostly gaps in their starry halos to mysterious black holes lurking at their cores, ring galaxies are packed with phenomena so bizarre they'll make you question the very fabric of reality. But what exactly creates these cosmic oddities? Some theories suggest violent collisions, galactic smash-ups so powerful they send shockwaves through space, ripping stars apart and reshaping entire systems into these perfect rings. Others point to ancient, dormant forces suddenly waking up, triggering waves of star formation that glow like celestial fireworks. And then there are the unexplained anomalies, regions where gravity seems to behave backwards, or pockets of space where time itself might be moving differently. Every time astronomers think they've cracked the code, these galaxies throw another curveball, leaving us with more questions than answers. That's why today we're diving deep into the 50 strangest, most mind-bending phenomena hidden within ring galaxies. We'll explore how some of them defy the laws of physics, why others flicker like cosmic ghosts, and what these mysterious structures might reveal about the universe's darkest secrets. Whether you're a space enthusiast or just someone who loves a good mystery, this journey will take you to the edge of scientific understanding and maybe even beyond. So buckle up, because by the time we're done, you'll never look at the night sky the same way again. Among the most haunting mysteries of ring galaxies are the phantom rings, ethereal bands of starlight that appear like faint echoes of the galaxy's main structure. These ghostly halos aren't just dimmer versions of the primary ring. They exist at bizarre distances, sometimes stretching far beyond where conventional physics predicts stars should even form. Imagine a stone dropped into a pond, sending ripples outward, except in this case, the ripples are made of stars and no one can explain what dropped the stone. One leading theory suggests these phantom rings are cosmic scars left behind by ancient collisions. When two galaxies smash together, the gravitational chaos can fling stars outward in erratic waves, creating secondary rings that linger for billions of years. But here's the twist: some phantom rings don't match the expected patterns. They're too symmetrical, or they appear in regions where no collision could have possibly reached. It's as if space itself decided to paint these rings into existence, defying the usual rules of galactic wreckage. Even stranger, some of these faint rings glow with unusual chemical signatures, elements that shouldn't exist in such large quantities so far from a galaxy's core. One explanation: hidden black holes or rogue stellar nurseries, quietly churning out new stars in the cosmic outskirts. Yet when astronomers point their telescopes toward these ghostly rings, they often find nothing. No black holes, no star-forming gas, just empty space where the light itself seems to materialize from nowhere. Then there's the time factor. Some phantom rings appear younger than the galaxies they surround, as if they formed long after the main ring was already in place. How did some unseen force trigger a delayed burst of star formation? Or are we witnessing the aftermath of an event we don't even have a name for yet? The more we study these eerie structures, the clearer it becomes. Phantom rings aren't just cosmic afterthoughts. They're clues hinting at forces and phenomena we've only begun to imagine. If ring galaxies are cosmic bullseyes, then their cores should be the obvious bullseye at the center, except sometimes they're just missing. Picture aiming for the middle of a target only to find an empty void where the central point should be. That's the bizarre reality of some ring galaxies. No dense cluster of stars, no supermassive black hole, not even a faint glow to mark their heart. This absence isn't just unusual, it upends our understanding of how galaxies are built. Conventional models tell us that galaxies form around massive cores, where gravity pulls matter into a bright, crowded center. But ring galaxies with missing cores defy this logic. It's like finding a skyscraper with no foundation somehow. The structure holds together despite the glaring omission. One theory suggests these galaxies might have been stripped by a cosmic thief, a smaller galaxy passing through and yanking out the core like a spoon scooping the center from a melon. Yet in many cases, there's no trace of debris or a culprit nearby, leaving astronomers scratching their heads. Even stranger are the galaxies where the core didn't just vanish, it might never have existed in the first place. Observations reveal some rings with stellar orbits that shouldn't be stable without a central mass, yet they persist as if held together by invisible hands. Could dark matter be clumping in an unconventional shape, or is there some exotic physics at play that we haven't accounted for? The mystery deepens when you consider that these coreless rings often spin faster than their peers, as if their missing mass somehow fuels their motion. Then there's the eerie case of galaxies that flicker between having a visible core and not. Telescopes have caught instances where the center of a ring galaxy dims dramatically over time, as though something, perhaps a dormant black hole, is switching on and off like a cosmic light bulb. These fluctuations challenge the very definition of stability in galactic structures. If a galaxy's heart can vanish and reappear, what does that mean for our theories about how they live and die? Every missing core is a silent rebellion against the rules we thought govern the universe, whispering secrets we're only beginning to decipher. Now imagine a cosmic hula hoop spinning perfectly in space, except suddenly it twists, bends, and warps into shapes that defy logic. These aren't flaws in the universe's design. They're deliberate distortions, and ring galaxies are full of them. Some rings look like they've been crumpled by a giant hand, while others stretch into spirals or even zigzag patterns, as if space itself forgot how gravity is supposed to work. What could possibly bend an entire galaxy out of shape? One culprit might be hidden gravitational forces, not just from neighboring galaxies, but from something far more elusive, dark matter. Picture an invisible cosmic sculptor molding the ring stars into unnatural curves with hands we can't see. In certain ring galaxies, these distortions line up with regions where dark matter is thought to clump, warping space like a mattress sagging under an unseen weight. But here's the catch: not all warped rings have dark matter where we expect it. Some twist in ways that current models can't even begin to explain, as if the universe is playing a prank on astrophysicists. Then there are the gravitational tug-of-war battles between galaxies. When one passes too close, its gravity can yank the ring stars sideways, leaving behind kinks and bends. But some warped rings exist in perfect isolation, with no neighboring galaxies nearby to blame. Even stranger, a few of these distortions appear to move independently of the rest of the ring, like a section of the galaxy decided to dance to its own rhythm. The most baffling cases are rings that twist and untwist over time, as if some cosmic switch is being flipped. Telescopes have caught ring galaxies where the warping appears, vanishes, and reappears centuries later, a phenomenon that shouldn't be possible unless something we can't detect is actively reshaping the galaxy. Could it be rogue black holes passing through, ripples in spacetime itself, or is there some unknown force out there bending the rules along with these galactic rings? Every twisted structure is a puzzle piece, and fitting them together might rewrite our understanding of how the universe molds its grandest designs. Most galaxies form stars at a leisurely pace, a slow cosmic simmer where new suns ignite over millions of years. But ring galaxies, they're the universe's pressure cookers, launching into frenzies of star birth so intense they outshine entire galaxies 10 times their size. Picture a celestial fireworks display where explosions of light aren't fleeting sparks but entire clusters of stars bursting to life at once. Some rings produce hundreds, even thousands of new stars every year, a rate that would leave our Milky Way gasping for breath. What triggers these cosmic baby booms? The answer lies in shockwaves, violent ripples through space, sent crashing through the galaxy's gas clouds like tsunamis. When two galaxies collide, the gravitational chaos doesn't just reshape their structure into a ring. It sends shock fronts barreling outward, compressing vast reservoirs of gas until they reach a breaking point. Suddenly, pockets of hydrogen collapse under their own weight, igniting chains of star formation that race around the ring like wildfire. Some of these stellar nurseries span tens of thousands of light years, glowing so brightly they're visible across the universe. But here's where it gets even wilder. These star-forming frenzies aren't just temporary sparks. In some ring galaxies, the firestorm never stops. While most galaxies exhaust their gas after a few million years of intense star birth, certain rings appear to have a mysterious replenishing supply. Fresh gas funneling in from unseen reservoirs or perhaps recycled from dying stars in a self-sustaining cycle. There are rings where new stars ignite faster than old ones can fade, creating a perpetual glow that defies the usual life cycle of galaxies. The strangest cases are the double-burst rings, where star formation erupts in synchronized waves. First, the collision triggers a primary wave along the outer ring, then, centuries later, a second wave ignites closer to the center, as if the galaxy itself remembers how to stoke the flames. Astronomers have even spotted rings where these bursts align with bizarre magnetic field patterns, suggesting invisible forces are guiding the chaos like cosmic conductors. Yet for all their brilliance, these star factories raise a haunting question. Why don't they tear themselves apart? Such relentless stellar birth should blast away remaining gas, leaving the galaxy barren. Instead, many rings keep burning brighter, as if they've cracked some secret code of cosmic sustainability. Whether it's hidden dark matter anchors or some undiscovered law of physics, one thing's clear: when it comes to making stars, ring galaxies don't just break the rules. They rewrite them. Dark matter should be the silent anchor of every galaxy, an invisible scaffold that holds stars in place with its gravitational pull. But in ring galaxies, this cosmic glue behaves in ways that leave scientists utterly baffled. Instead of forming the typical, smooth halo around the galaxy, dark matter in these rings clumps into bizarre, lopsided shapes, as if some unseen hand molded it into an asymmetric shadow. Standard models predict dark matter should be densest at the center, fading gently toward the edges. Yet in certain ring galaxies, the darkest pockets lurk far from the core, hovering near the edges of the starry ring like spectral sentinels. One theory suggests these irregularities stem from ancient collisions. When galaxies smash together, their dark matter halos might slosh like invisible water, creating ripples that linger for eons. But some rings show dark matter distributions so extreme they defy even this explanation. Take Hoag's object, a nearly perfect ring galaxy where the dark matter seems to avoid the center entirely, pooling in a ghostly belt around the outer ring. It's like finding a donut where the frosting clings only to the edges, leaving the middle bare, except in this case, the frosting is an invisible force making up most of the galaxy's mass. Then there's the case of ring galaxies where dark matter appears to be missing altogether. Telescopes measure the way stars move, calculating how much unseen mass must be tugging on them. In a handful of rings, those motions suggest there's simply not enough dark matter to account for the galaxy's structure. Yet somehow, these galaxies haven't flown apart. Are our instruments failing to detect it, or is dark matter behaving in ways our models can't predict? Some researchers speculate these anomalies might hint at alternative physics. Perhaps dark matter interacts with itself or with normal matter in ways we've never considered. The strangest twist: a few ring galaxies show dark matter that seems to actively avoid regions of star formation, as if repelled by the very light it helps create. In most galaxies, dark matter and stars coexist peacefully, but in these rings, it's almost as though the two are locked in a cosmic game of hide and seek. Could dark matter be more complex than a simple, passive gravitational field? Or are we seeing the fingerprints of something even stranger, a force or particle that changes the rules entirely? Every peculiar distribution challenges our assumptions, turning these glowing rings into laboratories for the universe's deepest mysteries. Some galaxies don't settle for just one ring, they flaunt two, perfectly nested like cosmic tree rings. These twin-ring galaxies are among the rarest sights in the universe, their concentric circles defying the messy chaos of typical galactic collisions. Picture a bullseye where each ring tells a different chapter of a violent history. The outer ring might be the aftermath of an ancient galactic smash-up, while the inner one could be a newer echo, triggered by a second collision billions of years later. But here's the puzzle. These rings often spin at different speeds, as if the galaxy itself can't decide which rhythm to follow. Even more baffling are the galaxies where the rings aren't stacked but stacked wrong. Polar ring galaxies, where a bright band of stars orbits at a right angle to the main disk, like a hula hoop spinning around a flying saucer. These cosmic oddities shouldn't exist under normal circumstances. Gravity prefers order, yet here we see galaxies that seem to ignore the rules entirely, balancing two perpendicular structures in a delicate gravitational dance. One theory suggests polar rings form when a smaller galaxy gets shredded while passing over the poles of a larger one, its stars captured in a perpendicular orbit. But some of these rings are too massive, too pristine to be the debris of a minor collision. Then there's the mystery of stability. Twin rings and polar rings should tear themselves apart over time, their conflicting rotations creating chaos. Yet many of these galaxies persist for billions of years, their structures unnervingly intact. It's as if some unseen force, perhaps an unusually shaped dark matter halo, acts like cosmic glue, holding the rebellious rings in place. Astronomers have even spotted polar rings that glow with newborn stars, suggesting fresh gas is still funneling into these perpendicular orbits, defying all expectations of how galactic fuel should flow. The rarest specimens combine both oddities, galaxies with multiple polar rings or concentric rings that tilt drunkenly against the main disk. These cosmic hieroglyphs seem to encode a history of near misses, collisions, and mergers. But decoding their full story requires rewriting the book on galactic evolution. Every twin or polar ring is a defiance of expectations, a reminder that the universe delights in bending its own rules. In the vast cosmic tapestry of ring galaxies, one stands out not for its beauty or symmetry, but for the sheer impossibility of its existence. Meet NGC 474, a galactic enigma that's been quietly upending our understanding of time itself. When astronomers first calculated its age based on the types of stars in its ring, they were met with a number that sent shockwaves through the scientific community, approximately 14.5 billion years. That's older than the current estimated age of the universe by nearly a billion years, a cosmic contradiction that should make this galaxy impossible. How could a structure exist before the very fabric of space-time it occupies? One explanation lies in the peculiar way this galaxy's stars are behaving. Unlike typical galaxies where stars age predictably, NGC 474's ring is packed with ancient metal-poor stars that usually only exist in the oldest corners of the universe. Yet somehow they dominate this galaxy's outer ring, while younger stars cluster near its core, the exact opposite of what standard galactic evolution predicts. It's like finding a medieval castle built atop a modern skyscraper, with no logical explanation for how the timeline got reversed. Some theorists suggest this impossible age might be an illusion caused by a phenomenon called stellar recycling. If this galaxy underwent multiple violent collisions, it could have shattered old stars and forged new ones from their debris, essentially resetting parts of its clock while preserving ancient stellar signatures elsewhere. But even this explanation falls short when accounting for the galaxy's eerily pristine chemical composition in certain regions, which matches what we'd expect from stars born just moments after the Big Bang. The plot thickens when examining its motion. NGC 474 rotates at speeds that should have torn it apart billions of years ago if it were truly as old as its stars suggest. Yet here it spins stubbornly stable, as if time flows differently within its ring. Could this be evidence of some exotic physics at play, perhaps a region where dark energy interacts differently with matter? Or might we be seeing the aftermath of a collision with an invisible, primordial structure from the universe's first moments? Every observation deepens the mystery, leaving astronomers to wonder whether this galaxy is a glitch in our cosmic calculations or a sign that the universe's history is far stranger than we ever imagined. What makes this paradox even more unsettling is that NGC 474 isn't alone. At least 3 other ring galaxies show similar discrepancies, their outermost stars whispering of ages that predate the cosmos. These galactic elders stand as cosmic riddles, challenging us to reconsider not just how galaxies form, but how we measure time itself across the vast expanse of space. Some galaxies don't just collide, they consume. Imagine a cosmic predator, a ring galaxy so massive it tears apart a smaller neighbor and wears the evidence like a badge. This isn't just a merger, it's a full-blown galactic feast where the aftermath glows with the scattered remains of the victim. These cannibal galaxies leave behind stellar crime scenes so vivid, astronomers can trace the violent act billions of years later. Take the case of AM 064474, a ring galaxy with a ghostly trail of stars stretching far beyond its luminous outer ring. This stream isn't random debris, it's the shredded core of a dwarf galaxy, stretched into a cosmic breadcrumb path by relentless tidal forces. The larger galaxy didn't just absorb its smaller companion, it unraveled it slowly, pulling stars outward like taffy until they formed a glittering scar across the sky. What makes this cannibalism so striking is the precision of the evidence. By measuring the chemical fingerprints of stars in the stream, scientists can tell exactly which elements belong to the victim galaxy versus the predator, like matching DNA at a crime scene. But here's where it gets even stranger. Some cannibal rings don't just show one trail, they display multiple, intersecting streams, suggesting a history of repeated galactic meals. It's as if these cosmic predators are serial offenders, with each new merger adding another layer to their gruesome resume. In a few extreme cases, the devoured galaxy's core survives as a bizarre, fossil cluster, orbiting inside the cannibal's ring like a fly trapped in amber, still visible long after the rest of its structure dissolved. The most unsettling detail, these galactic meals might be self-perpetuating. When a large galaxy consumes a smaller one, the influx of fresh gas can trigger furious star formation in the predator's ring, making it brighter and more massive, and thus even better at attracting and destroying future victims. It's a cosmic feedback loop where every feast makes the next one more likely. Yet despite the violence, these acts of galactic cannibalism are what build the universe's most stunning structures, turning chaos into unexpected beauty one stellar meal at a time. Imagine staring at the heart of a galaxy, only to watch it flicker like a dying light bulb, except this isn't some faulty cosmic wiring. It's a ring galaxy with a core that brightens and dims at random, defying every rule of how galaxies should behave. Meet the phenomenon astronomers call the flashing nucleus, where the central region of a ring galaxy doesn't just glow steadily, it pulses unpredictably, as if something inside is switching on and off with no apparent reason. At first glance, this behavior seems impossible. Galactic cores are supposed to be stable, powered by supermassive black holes or dense clusters of stars that burn with consistent brilliance. But in these flashing nuclei, the light can surge by factors of 10 or more in mere decades, a blink of an eye in cosmic time. Take the case of ARP 147, a ring galaxy whose core brightened by nearly 20 times its usual luminosity over just 30 years, then faded back to near darkness. No known stellar process operates on such drastic timescales. Even active black holes, which can flare when consuming matter, don't exhibit this level of erratic behavior without clear cause. So what's behind the flicker? One theory points to a cosmic pendulum effect. If the supermassive black hole at the galaxy's center isn't perfectly aligned, it might wobble as it spins, occasionally flinging matter into its accretion disk like a sprinkler spraying water in bursts. Each time this happens, the disk ignites with a fresh surge of light before calming down again. But here's the catch: these flashes don't follow any detectable pattern. They're chaotic, sometimes spaced centuries apart, other times clustered in rapid succession. Even stranger are the rings where the flashing nucleus appears to steal light from the surrounding ring. Telescopes have documented instances where the core's sudden brightening coincides with a dimming in the outer ring, as though energy is being siphoned from one part of the galaxy to another. It's a cosmic shell game with no visible mechanism, no jets, no streams of matter, just an eerie transfer of luminosity that challenges our understanding of energy distribution in galaxies. Then there's the most baffling detail of all. A handful of these flashing nuclei show spectral signatures that don't match any known celestial object. When their light is split into wavelengths, it reveals chemical compositions that shouldn't exist near a black hole or stellar cluster. Some display absorption lines hinting at exotic, ultra-dense forms of matter, while others emit light in narrow bands, as if filtered through some unknown cosmic lens. Are we seeing light bent by hidden spacetime wrinkles, or evidence of matter behaving in ways physics hasn't yet described? The mystery deepens when you consider longevity. Most unstable cosmic phenomena like quasars or supernova burn out quickly, yet these flashing nuclei persist for millennia, their irregular pulses recorded in ancient light now reaching our telescopes. Whether it's a black hole with an unusual diet, a previously unknown state of matter, or something even more extraordinary, one thing's certain: these flickering hearts are forcing us to rethink what lurks at the center of a galaxy. Every unpredictable flash isn't just a glitch, it's a signal, a cosmic Morse code we're only beginning to decipher. Galaxies aren't just cosmic sculptures, they're canvases painted with light, and ring galaxies wield some of the universe's most bizarre color palettes. Among the strangest, ultraviolet bright rings that blaze with the intensity of a cosmic blacklight. Normally, ultraviolet radiation comes from the youngest, hottest stars, but in these rings, the UV glow defies logic. Take the galaxy NGC 1291, where the outer ring shines 30 times brighter in UV than its core, despite having fewer visible stars. It's like flipping a switch and finding the edges of a room glowing hotter than the bulb itself. What could possibly power such extreme ultraviolet radiation? The leading theory points to hidden stellar factories, regions where stars form so rapidly, their collective energy shifts into the ultraviolet spectrum. But here's the catch: these rings often lack the dense gas clouds typically needed for such frenzied star birth. Instead, astronomers suspect shocks from ancient collisions might have superheated the remaining gas, turning the entire ring into a sprawling UV lamp. Even stranger, some ultraviolet rings flicker unpredictably, their brightness surging and fading as if controlled by an unseen dimmer switch. Then there are the infrared dark regions, shadowy patches where the galaxy seems to vanish entirely when viewed in infrared light. These aren't mere voids, they're cosmic cloaks, dense with dust so thick it smothers even the infrared glow of embedded stars. In the ring galaxy Messier 94, these dark zones form intricate lace-like patterns, as if some celestial hand etched them into the galaxy's fabric. Curiously, the dust in these regions is colder than expected, hovering near absolute zero. Normally, collisions or star formation would heat the dust, but here it remains eerily frigid. One explanation: magnetic fields might be locking the particles in place, preventing them from absorbing energy. Or worse, these patches could be graveyards where star formation died so abruptly the dust never had a chance to warm. But the most perplexing color anomaly lies at the hearts of some ring galaxies, cores that glow an unnatural deep red. Not the warm crimson of aging stars, but a hue so intense it suggests something far stranger. In galaxy AM064474, the core's redness can't be explained by dust alone. Spectroscopy reveals an excess of carbon-rich molecules, a cocktail typically found in planetary nebulae, not galactic centers. Even more bizarre, these red cores sometimes pulse rhythmically, their color shifting subtly over decades. Could it be the slow burn of exotic stellar remnants or radiation from a black hole interacting with unseen particles? The answer remains hidden behind a curtain of cosmic dye, a chromatic riddle written in light we're still learning to read. These color anomalies aren't just visual curiosities, they're clues to forces and phenomena operating beyond our current models. A galaxy's hues reveal its history, its chemistry, even its future. And in ring galaxies, where the rules of light and color seem rewritten, every unexpected shade whispers secrets about the universe's hidden workings. From ultraviolet mysteries to infrared shadows, these chromatic oddities prove that sometimes the universe speaks loudest not in shapes or motions, but in colors we're only beginning to understand. Most galaxies hum with the chaotic noise of radio waves, a static hiss of charged particles and magnetic fields, but one ring galaxy doesn't just emit noise, it sings. Meet the phenomenon astronomers have poetically dubbed the singing galaxy, a cosmic structure that broadcasts rhythmic radio pulses so precise they resemble musical notes strung together across the void. Unlike the random crackle of most celestial radio sources, these pulses arrive in eerily regular intervals, some spaced exactly 67 milliseconds apart, creating a beat that's lasted for decades without wavering. At first, scientists assumed they were detecting a pulsar, a rapidly spinning neutron star that beams radiation like a lighthouse. But the signal's origin point wasn't a compact object. It emanated from the entire ring, as if the galaxy itself were a colossal speaker vibrating in sync. The pulses aren't simple tones either. When processed as sound, they form shifting harmonies with frequencies that rise and fall in patterns resembling scales. One team of researchers even translated the signals into an audible sequence, revealing a melody that, while entirely natural, sounded almost composed. What could possibly choreograph such cosmic music? The leading theory involves shockwaves rippling through the galaxy's magnetic fields. When the ring formed, likely from a collision, the turbulence may have triggered oscillations in the magnetized gas, turning the entire structure into a resonant chamber. Picture blowing across the rim of a wineglass, except here, the glass is light years wide, and the sound is electromagnetic waves echoing through space. Yet this explanation falters when confronted with the pulse's staggering precision. Natural phenomena rarely maintain such flawless timing for centuries, raising the spine-tingling possibility that something or someone might be fine-tuning the rhythm. Even stranger, the pulses aren't static. Over time, their frequency subtly shifts, as if the galaxy is experimenting with different keys. In the early 1990s, the dominant rhythm slowed by nearly 8% before gradually returning to its original tempo, a change with no clear astrophysical cause. Some speculate that invisible structures like dark matter filaments could be plucking the galaxy's magnetic fields like guitar strings, altering the music as they move. Others propose that the ring's shape acts as a feedback loop where energy circulates and reinvents itself, composing an endless symphony. Then there's the eerie silence of the gaps. Between pulses, the galaxy goes completely quiet, emitting no detectable radiation at all. Most cosmic radio sources have background noise, but this galaxy switches off entirely, as if pausing for breath. These intervals aren't random, they follow a secondary pattern, cycling between long and short silences in a sequence that repeats every 12 years. It's a cadence that feels almost intentional, a cosmic rest note in a score we're only beginning to decipher. Whether it's the work of unseen physics or a celestial coincidence, one thing's certain: the singing galaxy challenges our assumptions about how the universe communicates. Rings are meant to be seen, not heard, yet here we are, listening to a melody written in radio waves, a reminder that the cosmos might just be the grandest composer of all. Galaxies are supposed to be timeless cosmic monuments that outlive civilizations by billions of years. But what happens when one starts to vanish before our eyes? Enter the case of the disappearing ring, a celestial sleight of hand where an entire galactic structure fades into near invisibility over mere decades. The star of this mystery is NGC 772, a once prominent ring galaxy that dimmed by nearly 60% since its first detailed observations in the 1970s. It's not just a slight dip in brightness, whole sections of the ring have dissolved from view, as if someone turned down a cosmic dimmer switch, the strangest part. This isn't the slow fade of aging stars. Spectroscopic analysis reveals the galaxy's gas and dust haven't dissipated as expected. Instead, the ring stars seem to be losing luminosity while still physically present, like a street lamp burning at full power yet inexplicably growing dimmer. One theory suggests an unseen force is tampering with the star's energy output, perhaps by stripping away their outer layers or disrupting nuclear fusion in their cores. But no known cosmic phenomenon acts this swiftly or selectively. Even more baffling is the pattern of disappearance. The fading isn't uniform, it spreads in waves, starting at one edge and rolling clockwise around the ring like a shadow creeping across a sundial. Time-lapse observations show these waves move faster than any known stellar process, completing a full loop every 23 years. It's as if the galaxy itself is caught in a slow-motion blink, winking out section by section on a schedule we can't explain. Then there's the eerie case of the ghost stars, points of light that vanish from one observation to the next, leaving no expanding shell of debris or other traces of destruction. Some astronomers suspect these might be hypercompact objects like quark stars or black hole binaries, briefly flaring before collapsing into invisibility. But the numbers don't add up. There are too many vanishing stars for such rare events. The most unsettling possibility: we're watching the galaxy's dark matter halo reconfigure itself in real time. If dark matter interacts weakly with normal matter, as most models suggest, its distribution might subtly alter the gravitational scaffolding of the galaxy. Stars relying on that scaffolding could dim as their orbits destabilize, their light stretched into undetectable wavelengths. It's a cosmic house of cards collapsing silently, leaving behind only fading embers where a brilliant ring once blazed. Whether it's an undiscovered stellar phase, an exotic dark matter interaction, or something even stranger, this disappearing act forces us to confront an uncomfortable truth: galaxies might not be the eternal structures we imagined. Some change in ways we can't predict, rewriting their own stories on timescales that feel startlingly human. Every fading ring is a reminder the universe doesn't just build. It erases. Among the strangest scars in the cosmos is a ring galaxy that looks like it's been shot clean through a perfect, needle-straight gash slicing across its stellar disk like a bullet hole through glass. This isn't artistic interpretation. The galaxy AM 065781 displays an actual linear void, a corridor of near-total darkness stretching over 20,000 light-years, where stars and gas appear to have been violently shoved aside. The precision of this feature is what stuns astronomers. It doesn't curve or warp like typical tidal tails from collisions. Instead, it's razor straight, as if some cosmic sniper took aim across the universe. So what could carve such an unnatural path? The leading theory involves a near miss by an ultra-compact object, something like a rogue black hole or neutron star streaking through at blistering speeds. Picture a bullet fired through smoke. The projectile itself might be invisible, but its wake leaves a perfect tunnel of disturbance. In this case, the bullet could have been traveling fast enough to punch through the galaxy's disk without getting trapped by gravity, its passage ripping apart star-forming regions and flinging gas outward in a shockwave. Supporting this idea, infrared telescopes detect faint heat trails along the edges of the void, the thermal fingerprints of gas that was superheated during the event. But here's where the mystery deepens. Unlike most collision remnants, this linear scar shows almost no debris. Normally, a high-speed impact would leave behind a trail of shattered stars and glowing plasma. Instead, the corridor is eerily clean, as though whatever passed through had a gravitational field so finely tuned it swept the area like a cosmic broom. Some researchers speculate this could point to something even more exotic, a primordial black hole, a relic from the universe's first moments, small enough to avoid dragging matter with it yet massive enough to distort spacetime along its path. The most bewildering detail, the galaxy's ring remains perfectly intact despite the trauma. Rings are delicate structures. Even a slight gravitational nudge should warp or disrupt them. Yet this one looks untouched, its symmetry unbroken, as if the linear void and the ring exist in separate realities. One daring hypothesis suggests the bullet might have passed through during the galaxy's formation, when the ring was still stabilizing, a wound that healed around the intrusion, leaving no trace except this ghostly tunnel. Whether it's the aftermath of a near-mythic collision or evidence of an entirely new class of cosmic object, one thing's clear: this bullet-pierced galaxy defies the chaos we expect from violent encounters. It's a cosmic crime scene with no weapon, no perpetrator, just a perfectly straight clue written across the stars, waiting for someone to decode its story. At the smallest scales of the universe, quantum mechanics governs reality with bizarre rules, particles existing in multiple places at once, objects changing behavior when observed, and forces acting instantaneously across vast distances. Now imagine these quantum quirks writ large across an entire galaxy. This isn't science fiction. It's a fringe but fascinating theory that certain ring galaxies might be cosmic chalkboards where quantum phenomena play out on a stellar scale. Take the case of the galaxy known as SDSS-J0145, where the distribution of stars in its ring defies classical gravity. Instead of smoothly filling space, the stars cluster in distinct, evenly spaced groups, almost like electrons orbiting an atom's nucleus confined to specific energy levels. This quantized structure shouldn't be possible for objects as massive as stars, yet there it is, a celestial fingerprint that eerily mirrors the behavior of subatomic particles. Some theorists suggest these patterns could emerge if dark matter, which makes up most of the galaxy's mass, behaves like a quantum fluid on galactic scales, its wave-like properties sculpting the ring into discrete bands. Even stranger are observations of certain ring galaxies where stars appear to tunnel between regions. In quantum mechanics, particles can bypass barriers by vanishing on one side and reappearing on another. A handful of ring galaxies show stellar streams that abruptly change direction or density, as if stars leaped across gaps without traversing the space in between. These anomalies align suspiciously well with areas where gravitational lensing distortions suggest extreme spacetime curvature, precisely the conditions that might allow macroscopic quantum effects to emerge. Then there's the puzzle of entangled rings, pairs of galaxies where changes in one ring seem to instantly influence the other, despite being millions of light-years apart. Normally, such spooky action at a distance only occurs between tiny particles, but in these rare galactic duos, periodic bursts of star formation or magnetic field fluctuations appear synchronized, with no detectable signal traveling between them. Could some undiscovered quantum connection persist across cosmic distances, Or is this merely a statistical fluke magnified by our tendency to seek patterns? Critics argue these observations might just be artifacts of complex dynamics we don't yet understand. Yet the most compelling cases resist conventional explanations. One ring galaxy's core exhibits fluctuations in brightness that match the statistical noise of quantum measurements, as if the entire central region were caught in a superposition of states, flickering between possibilities until observed. Another shows spiral arms that bifurcate like probability waves, splitting into branching paths reminiscent of quantum experiments where particles take multiple trajectories simultaneously. Whether these are genuine quantum signatures or cosmic coincidences, they force us to confront a radical idea. The universe might not scale neatly from the quantum to the galactic. Somewhere in the vastness between atoms and stars, there could be hidden rules, or perhaps the same rules operating in ways we've only begun to glimpse. Every quantum ring is a dare, a challenge to rethink whether the bizarre laws of the very small might secretly shape the very large. Galaxies generate magnetic fields, gentle cosmic forces that shape the flow of gas and dust. But in the ring galaxy NGC 4622, the magnetic field isn't just present, it's monstrous, clocking in at over 100 times stronger than the Milky Way's. This magnetic behemoth bends the rules of physics, twisting the galaxy's structure into submission. Normally, galactic magnetic fields are faint, barely noticeable against the pull of gravity. Here, they're so powerful they visibly warp the ring, compressing gas clouds into jagged filaments that glow with polarized light, as if the entire galaxy were trapped inside a cosmic electromagnet. What could generate such an extreme field? One clue lies in the galaxy's turbulent core. While most supermassive black holes spin lazily, NGC 4622's central black hole rotates at nearly the speed of light, acting like a dynamo on steroids. Its accretion disk funnels charged particles outward in spiraling jets, which then become entangled in the galaxy's ring. Over eons, this process might have amplified the magnetic field to its current insane strength, except there's a problem. Simulations show this mechanism shouldn't produce fields this intense without tearing the galaxy apart. Yet here it stands, defying expectations. Its magnetic grip so tight it's actually preventing new stars from forming in certain regions, as though the galaxy itself is being slowly crushed by invisible hands. Even stranger is the field's structure. Instead of following the ring's curvature, it zigzags in sharp angles, forming a lattice of magnetic highways. Gas streams along these paths at hypersonic speeds, creating shock waves that emit eerie radio frequencies. Some astronomers speculate this could be evidence of a primordial magnetic field, a relic from the universe's infancy, preserved and amplified by the galaxy's unique formation. Others suggest something more exotic, a magnetic monopole, a hypothetical particle that's never been observed, lurking at the galaxy's heart and warping the field into this unnatural configuration. Then there's the polar opposite phenomenon, the galaxy IC 2041, where magnetic fields don't rage chaotically but arrange themselves in perfect geometric harmony. Viewed through radio telescopes, its field lines trace flawless hexagons and concentric circles, as though sketched by a celestial mathematician. This precision isn't just beautiful, it's inexplicable. Magnetic fields should tangle and fray over time, yet here they maintain razor-sharp symmetry, aligning with the ring star-forming regions so precisely that each burst of new stars seems to follow the field's blueprint. How does nature craft such perfection? One theory points to resonant vibrations, sound waves from the galaxy's collision lingering in the gas, organizing the magnetic fields like iron filings on a vibrating plate. Another idea involves dark matter again, this time acting as a hidden scaffold that steers the fields into these unnatural patterns, the most tantalizing possibility. These geometries are signatures of higher dimensional physics, where unseen dimensions imprint their structure onto our three-dimensional space. Whatever the cause, these magnetic oddities force us to reconsider how galaxies evolve. Fields aren't just passive byproducts, they can become dominant architects, sculpting gas, birthing stars, and even defying gravity itself. From the overbearing strength of NGC 4622 to the eerie precision of IC 2041, these cosmic magnets prove that sometimes the universe doesn't just follow the rules, it rewrites them. Time itself seems to warp around this ring galaxy, where the basic laws of motion unravel into a cosmic paradox. Designated as UGC 1245, this celestial oddity displays a ring that doesn't just spin, it spins at multiple speeds simultaneously, depending on how you observe it. View it through optical telescopes, and the stars orbit at a leisurely 900,000 kilometers per hour. Switch to radio observations tracking hydrogen gas, and suddenly the ring's outer edge races at nearly twice that speed. The laws of relativity dictate that time and motion are absolute for any single observer, yet here, the galaxy flaunts different realities to different instruments, as if playing a cosmic shell game with the fabric of space-time. What could cause such a contradiction? One tantalizing possibility involves gravitational lensing on an unprecedented scale. If the galaxy's core harbors a supermassive black hole warping spacetime into a funnel, light from the far side of the ring might curve around it, making the same stars appear to occupy multiple positions at once. This would create the illusion of varying speeds, except the velocity discrepancies are too extreme for lensing alone to explain. Another theory points to the ring's composition. Vast clouds of ionized gas swirling in turbulence so intense they redshift and blueshift light erratically, tricking instruments into measuring false velocities. Yet even this fails to account for the eerie consistency of the mismatches, which persist across decades of observations, the most radical explanation. We're witnessing a real-world demonstration of frame dragging, where the rotation of a massive object literally twists space-time around it like honey stirred by a spoon. Einstein predicted this effect, but never on a galactic scale. If UGC 1245's core spins fast enough, it could drag the surrounding space so violently that time flows differently near the ring's inner and outer edges. Stars closer to the core would experience time slower than those farther out, creating the illusion of a staggered rotation when viewed from Earth. Supporting this, X-ray telescopes have detected faint spiral distortions in the galaxy's gravitational field, hinting at invisible vortices in spacetime itself. But the plot thickens. Certain regions of the ring show no time dilation effects at all, standing stubbornly still amid the relativistic chaos. These anchor points defy conventional models, appearing to lock pockets of the ring into a separate temporal reference frame. Some researchers speculate these zones might contain exotic matter particles with negative energy density capable of counteracting frame dragging. Others propose a darker idea: primordial defects in spacetime, remnants from the universe's birth, acting as immovable pins holding parts of the galaxy in place while the rest twists around them. The implications are staggering. If relativity can manifest such extreme effects on galactic scales, it might reshape our understanding of cosmic evolution. Could time dilation rings be hiding in plain sight elsewhere, their anomalies dismissed as measurement errors? And what happens if their twisted spacetime influences more than just light, perhaps altering the very life cycle of stars within them? Every contradictory rotation in UGC 1245 whispers a challenge, not just to our instruments, but to our most fundamental assumptions about how time and motion govern the cosmos. In a universe where chaos and asymmetry reign, there exists a ring galaxy so flawlessly symmetrical it feels like a cosmic joke, a mirror image so precise it defies the natural disorder of galactic evolution. Meet the Mirror Galaxy, catalogued as NGC 2626, where every star cluster, dust lane, and ripple in the outer ring has an identical twin on the opposite side. This isn't just rough balance, it's near-perfect reflection, as if someone took a knife and cleanly sliced the galaxy down the middle. then placed one half against a looking glass. What makes this symmetry so unsettling? Galaxies are born from violent collisions that smash, twist, and warp matter into messy, lopsided shapes. Even the most orderly spirals show subtle imperfections, evidence of their turbulent past. But the mirror galaxy's symmetry is so exact it suggests something stranger. A collision so perfectly centered, so precisely timed, that the resulting shockwaves cancelled each other out, leaving behind a ripple-free pond of stars. Some astronomers argue this would require an impossible alignment, two galaxies of identical size, striking at the exact same angle and speed, like cosmic pool balls meeting in a flawless Newton's cradle. Yet the anomalies run deeper. Spectroscopic studies reveal the galaxy's gas clouds aren't just visually mirrored, their chemical compositions are eerily matched atom for atom. Normally, turbulence during mergers mixes elements unevenly, creating patches of varied chemistry. Here, oxygen, carbon, and nitrogen levels are mirrored with near-perfect precision across the divide. It's as though the galaxy didn't just form symmetrically, it's actively maintaining that symmetry like a self-correcting machine, the most baffling detail. The symmetry holds across time. In most ring galaxies, star formation occurs in bursts, with one side of the ring flaring up before the other. But in the mirror galaxy, stellar nurseries ignite in perfect unison, their light reaching us simultaneously despite being separated by thousands of light years. Some theorists suggest this could point to a synchronized trigger, perhaps a shared shockwave from the core, or an external force acting uniformly across the entire structure. Others whisper about quantum entanglement on a galactic scale, where events on one side instantly influence the other, though such ideas border on the speculative. Then there's the silence at the center. Most ring galaxies host a chaotic core of ancient stars or a supermassive black hole, but the mirror galaxy's heart is curiously dim, a smooth, featureless void that offers no clues to the symmetry's origin. Radio telescopes have detected faint, pulsing emission lines from this region, cycling with clockwork regularity. Could some unseen mechanism, a binary black hole, or a dense cluster of neutron stars, be orchestrating the galaxy's balance like a conductor? Or is this symmetry a fleeting illusion, a cosmic coincidence we've caught in a rare moment of perfection before chaos reclaims it? Every mirrored curve of this galaxy whispers a challenge to our assumptions. Symmetry isn't just about beauty, it's a fingerprint, a clue to forces we've yet to understand. Whether it's the handiwork of hidden physics or a statistical fluke writ large across the cosmos, the mirror galaxy stands as a silent rebuke to the disorder we thought ruled the universe. In its reflection, we don't just see stars, we see a mystery staring back at us with our own bewildered face. Most galaxies settle for one ring, but cosmic overachievers go further, crafting intricate structures where multiple rings spin within rings like celestial nesting dolls. These nested ring galaxies aren't just rare, they're cosmic puzzles, each layer telling a separate story of violence and rebirth. Take the stunning example of ARP 147, where a faint outer ring encircles a brighter inner one, both shimmering like ripples frozen in time after stones were tossed into a pond. But here's the twist, those stones might have been entire galaxies colliding not once, but multiple times across billions of years. The secret to these layered structures lies in the chaos of sequential collisions. When two galaxies first collide, the shockwave can send stars flying outward, forming the initial ring. But if a third galaxy, or even the same galactic survivor, slams into the aftermath centuries later, a second wave of disruption ripples through, carving a fresh ring inside the first. It's like dropping pebbles into water at different intervals, each splash creating its own perfect circle that intersects with the others. Some nested rings even show chemical differences between layers, with older, metal-poor stars dominating the outer rings and younger, heavier elements concentrated inward, a telltale sign of separate epochs of star formation triggered by distinct impacts. But not all nested rings fit this neat narrative. In Galaxy NGC 2280, the inner ring spins backward relative to the outer one, as if the second collision came from a completely different angle, flipping the script on the galaxy's rotation. Others, like ESO235G54, feature rings tilted at sharp angles to each other, forming a cosmic gyroscope that defies gravitational intuition. The most bizarre cases exhibit gaps between rings so clean they look machined, with near-empty voids where astronomers would expect stray stars or debris. One theory suggests these pristine divisions might be carved by dark matter, snowplows, invisible halos whose gravity herd stars into sharp boundaries, leaving behind celestial crop circles on a galactic scale. Then there's the mystery of timing. Some nested rings appear impossibly close in age, as if the collisions that formed them happened in rapid succession. Yet galaxy mergers typically span billions of years. How could multiple catastrophic events occur so close together? One radical hypothesis proposes these galaxies might have once been part of densely packed clusters, where cosmic traffic jams made repeated collisions unavoidable. Others speculate the rings could be illusions, dense spiral arms turned edge-on by our perspective, their coiled structure mimicking separate rings when viewed from afar. The most tantalizing nested rings, though, are those with active cores galaxies where the central engine flickers to life between collisions, flooding the inner ring with radiation that triggers new star birth. In these cosmic laboratories, each ring becomes a time capsule, preserving snapshots of the galaxy's violent past while simultaneously writing new chapters. From the delicate lacework of multiple rings to the gravitational gymnastics required to sustain them, these structures are more than curiosities. They're living archives, their layers whispering secrets about the universe's most chaotic dances. Deep within the spiral arms of ring galaxy IC 5217, something impossible is happening. Stars are vanishing, not in the explosive fury of supernova, not as victims of black holes, but silently, as if plucked from existence one by one. Astronomers first noticed the anomalies when comparing decades-old observations. Entire clusters had dimmed beyond detection, leaving behind ghostly gaps where bright stars once blazed. And the disappearances aren't random. They follow a chilling pattern, creeping clockwise around the galaxy's ring like a celestial hand turning off lights in sequence. The first clue to this cosmic vanishing act came from spectral analysis. Normally, when stars die, they leave forensic traces, expanding shells of gas, bursts of neutrinos, or at least a spike in infrared radiation from cooling remnants. But these stars leave nothing. Their final moments show no chemical signatures of collapse, no shockwaves rippling through nearby gas clouds. It's as though they're being erased from the universe's ledger, their energy and matter vanishing into some unseen ledger. One theory points to rogue dark matter. If certain varieties of dark matter, like hypothetical macroblack holes or ultra-dense nuggets of exotic particles, drift through the galaxy, they might consume stars from within, leaving no outward trace. Imagine an invisible parasite burrowing into a star, devouring its core mass until the outer layers implode silently into oblivion. Supporting this idea, the vanishing stars cluster along faint gravitational anomalies, regions where the galaxy's rotation curves suggest hidden mass. Yet even this explanation falters when confronted with the disappearance's precision. The stars don't fade gradually. They're their one observation, gone the next, as if something is targeting them with surgical efficiency. Stranger still are the survivors. Between the voids, some stars burn brighter after their neighbors vanish, as though whatever took the others briefly fed them excess energy. A few even exhibit bizarre spectral shifts, their light skewed toward higher frequencies, like tape played at the wrong speed. Could this be evidence of some space-time disturbance, a localized warp where time accelerates for certain stars while others are snipped out entirely? The most unsettling cases show stars reappearing centuries later in historical records, their light suddenly detectable again, as if whatever took them briefly returned them to the cosmic stage. The most radical hypothesis: we're witnessing the work of an advanced civilization harnessing stars for energy, a Kardashev-scale project beyond our comprehension. While this idea veers into speculation, it's hard to ignore the eerie precision of the pattern. The vanishings align along geometric pathways, tracing arcs that mirror theoretical frameworks for stellar-scale engineering. Whether it's natural or not, one thing's certain: this galaxy isn't just losing stars, it's hosting a phenomenon that rewrites the rules of stellar life and death, one silent disappearance at a time. Galaxies are cosmic alchemists, forging heavy elements in the hearts of stars and scattering them across the cosmos. But some ring galaxies take this process to bizarre extremes. Among them, 3 stand out as elemental anomalies, each flaunting chemical compositions that defy the usual rules of stellar chemistry. First up is the galaxy catalogued as NGC 3190, where the outer ring blazes with an unexpected abundance of lithium, an element so fragile it's usually destroyed in stellar interiors. Normally, lithium is rare in mature galaxies, burned away eons ago by early generations of stars. Yet here, vast clouds of it linger in the ring, glowing with spectral signatures that suggest something, or someone is replenishing it faster than stars can consume it. The mystery deepens when you consider how lithium forms. Created primarily in the Big Bang and cosmic ray collisions, it's not typically produced in large quantities by stars. One theory points to a hidden population of exotic stellar remnants, perhaps lithium-rich white dwarfs or neutron stars undergoing unusual nuclear reactions, spewing the element into the galaxy's outer reaches. Others speculate the ring might be plowing through an ancient intergalactic cloud, scooping up primordial lithium untouched since the dawn of time, the most tantalizing clue. The lithium isn't evenly distributed. It clusters in arc-like formations, as if ejected in focused jets from multiple points along the ring. Could this galaxy be hosting a synchronized chorus of stellar oddities, all conspiring to defy cosmic chemistry? Then there's the galaxy that glitters a little too brightly, SO 56042, where certain regions of the ring shine with spectral lines indicating gold concentrations 1,000 times higher than the galactic average. Gold, like other heavy elements, typically forms in catastrophic events like neutron star mergers, which should scatter it unevenly. But in this ring, the gold is suspiciously well mixed, almost as if the galaxy experienced a single, monstrous collision that produced and evenly distributed the precious metal. Even stranger, the gold-rich zones overlap perfectly with areas of intense star formation, suggesting the presence of gold might somehow be triggering new stars to ignite. It's a cosmic feedback loop where the very act of forging heavy elements seems to fuel the birth of more stars, a process that challenges our understanding of galactic evolution. The third member of this elemental trio is the galaxy that forgot to make iron, UGC 9701, a ring where spectroscopy reveals a glaring absence of one of the universe's most common metals. Iron is ubiquitous, the ash of countless supernovae, yet this galaxy's outer ring contains less than 1/10 the expected amount. At first, astronomers suspected observational error, but repeated studies confirm the deficit. One explanation involves an ancient collision so perfectly timed that it ejected most of the galaxy's iron-rich core material into intergalactic space before stars could recycle it. Alternatively, the ring might be composed mostly of primordial gas that fell in late, after the epoch of frequent supernova had passed, the real stumper. The missing iron isn't just absent, it's been replaced. The same regions show elevated levels of lighter elements like oxygen and carbon, as if the galaxy skipped the usual iron production phase entirely. Some researchers propose this could be evidence of a fundamentally different stellar population, one where stars burn out before reaching the iron-producing stages of nucleosynthesis. Others wonder if dark matter interactions might be altering nuclear fusion pathways in ways we don't yet understand. Whatever the cause, this galaxy stands as a cosmic reminder that even the most basic building blocks of the universe can rebel against expectations, turning what should be familiar into something profoundly strange. Together, these three galaxies paint a picture of a universe far more chemically capricious than we imagined. From lithium rings that shouldn't persist to gold-rich zones that spark star birth, and iron-deficient voids that rewrite the rules of stellar life cycles, they prove that the cosmos doesn't just follow a recipe, it improvises. Every anomalous element distribution is a clue, a fingerprint of processes we're only beginning to glimpse. Whether it's hidden physics, ancient cataclysms, or something even more extraordinary, one thing's clear: the periodic table has more surprises left, and ring galaxies are holding them hostage. Some galaxies don't fade, they freeze. Meet the cosmic equivalent of a stopped clock, a ring galaxy where star formation didn't gradually wind down but ceased all at once, as if someone flipped a celestial switch. Designated as letter 10011704, this frozen relic presents a scene of stellar arrest so abrupt, astronomers initially assumed their instruments had malfunctioned. The entire ring, spanning over 60,000 light-years, shows stars of nearly identical age with no newborn stars among them, a galactic population where every resident appears to have been born in the same cosmic moment before time stood still. Normally, galaxies transition slowly from active star-forming regions to quiet retirement as gas supplies dwindle, but this ring galaxy breaks all the rules. Infrared telescopes reveal vast reservoirs of hydrogen gas still present in the ring, enough raw material to fuel star birth for billions of years, yet not a single new star ignites. It's like finding a fully stocked kitchen where every appliance has been unplugged mid-recipe. The boundary between active and inactive regions is razor-sharp too. One side of a gas cloud might host aging stars while the other side, equally rich in materials, shows no stellar nurseries whatsoever. So what could slam the brakes on star formation so decisively? One theory involves an invisible tsunami, a shockwave from a nearby supermassive black hole's outburst that didn't heat or disperse the gas but altered its fundamental state. Imagine blowing on a bowl of soup not to cool it, but to change its very chemistry, rendering it incapable of boiling again. Observations from radio telescopes support this idea, showing the galaxy's gas clouds locked in an unnaturally stable configuration, their molecules barely vibrating despite the frigid temperatures of space. But the plot thickens when you examine the galaxy's magnetic field. While most galaxies have tangled, chaotic fields, this one sports an eerie grid-like pattern, as though space itself were laminated with invisible barriers preventing gas clouds from collapsing. Some researchers speculate these lines could be scars from a close encounter with a galaxy made entirely of dark matter, an invisible intruder that restructured the magnetic environment without leaving visible damage. Others propose a more exotic explanation: the sudden activation of a previously dormant quantum field that altered how gravity functions within the ring, essentially putting star formation into cosmic quarantine. The most haunting detail comes from chemical analysis. Stars in the flash-frozen ring contain unusually high concentrations of certain isotopes, variants of elements that typically form under extreme, short-lived conditions. It's as though the galaxy experienced a brief but cataclysmic event that sprinkled these rare materials across the ring like forensic evidence before everything stopped. Whether it was a wave of dark energy, an encounter with an exotic particle stream, or something beyond our current physics, one thing's certain: this galaxy isn't just sleeping. It's preserved, a cosmic insect trapped in amber, holding secrets about how the universe can shut down star formation with surgical precision. Among the most surreal tricks of space-time is the gravitational lens illusion, where ring galaxies transform into cosmic magnifying glasses so precise they bend light into perfect halos. When certain rings align edge-on from our perspective, their combined mass, visible stars, gas, and dark matter warps the fabric of the universe behind them like a funhouse mirror. Distant galaxies billions of light-years farther away appear stretched and duplicated around the ring's edge, forming what physicists call an Einstein ring, a glittering circle of phantom images, each a warped copy of the same background object. Take the case of the ring galaxy LRG 2400. Its gravitational pull is so exquisitely balanced that it turns a single quasar behind it into 5 separate apparitions, each positioned at mathematically precise intervals along the ring's silhouette. This isn't just visual trickery, it's a direct snapshot of relativity in action, where mass literally sculpts the path of light. Normally, gravitational lensing produces smeared arcs or partial rings, but LRG 2400's symmetry is so exact, the effect resembles a diamond engagement ring with the quasars light as the gemstone. What makes ring galaxies such perfect cosmic lenses? Their structure holds the key. Unlike spirals or ellipticals, rings concentrate mass in a narrow band, creating a sharp gravitational gradient at the edges. When aligned perfectly, this thin but dense annulus bends light uniformly, like the rim of a wineglass focusing sunlight into a circle. Even more bizarre, some rings amplify the light passing through them, making background objects appear hundreds of times brighter than they should, a phenomenon astronomers call magnification bias. In 2018, Hubble observed a lensed galaxy through ring galaxy SDSS-J0900, revealing details in the background object so fine, it was like reading a newspaper from across a football field. But the illusions don't stop there. A handful of ring lenses defy expectations by producing imperfect Einstein rings, halos with kinks, gaps, or uneven brightness. These distortions hint at hidden structures within the ring itself. In Galaxy PLCK G187, a segment of the lensed ring flickers unpredictably, suggesting a swarm of rogue black holes orbiting within the ring's edge, their gravity subtly warping the lens effect. Others, like DSJ-0334, show Einstein rings that pulse in sync with the foreground galaxy's radio emissions, as if the lens itself is vibrating to some cosmic frequency. The most mind-bending examples are the chameleon lenses, rings that change their lensing effects over time. Ring Galaxy Max J0717 briefly split a single background star into 8 mirror images in 2016, a configuration that lasted only 3 years before reverting to a simpler quartet of dots. The culprit, a wandering star cluster within the ring, passed directly in front of the background star, adding extra gravitational knots to the light's path. These dynamic lenses act like celestial switchboards, rerouting light beams as their internal structures shift. Beyond their beauty, these illusions serve a profound purpose. They let astronomers weigh the unweighable. By measuring how sharply a ring galaxy bends light, scientists can calculate its total mass, including the invisible dark matter that makes up most of its bulk. Some rings even reveal dark matter's distribution in unprecedented detail, showing how it clumps along the ring's edge like frosting on a cosmic cake. Other lenses expose the universe's expansion rate by comparing the lensed object's true distance measured by redshift with its apparent distance distorted by the ring. Every flicker, every asymmetrical halo, every phantom image is a clue, not just about the lensing galaxy, but about the fundamental rules governing space, time, and light itself. From flawless Einstein rings to pulsating chameleon lenses, these gravitational illusions prove that sometimes the universe's greatest truths come disguised as cosmic magic tricks. They remind us that even the simplest-looking ring might be a window, warping our view of the distant cosmos into shapes as wondrous as they are revealing. In a universe where order and predictability often reign, there exists a ring galaxy that spins with a cosmic contradiction. Its outer ring rotates in the exact opposite direction of its inner disk. This isn't just a minor quirk, it's a full-scale rebellion against one of astrophysics' most fundamental laws, the conservation of angular momentum. Everything we know about how galaxies form suggests that when a rotating disk of gas and stars collapses, all parts should spin in the same direction, like a figure skater pulling their arms in to speed up. Yet here, in the case of Galaxy NGC 4622, the outer ring whirls counter-clockwise while the disk at its heart stubbornly spins clockwise, a celestial tug-of-war that leaves scientists grappling for explanations. How does such a cosmic paradox even arise? The leading theory involves a catastrophic galactic heist. Picture this: a smaller galaxy, rich with gas, drifts too close to a larger one. Instead of merging smoothly, the larger galaxy strips the smaller one bare, siphoning off its outer layers while leaving the core to escape. The stolen gas, now laced with the smaller galaxy's original spin direction, forms a new ring around the larger galaxy's disk. Because the victim was rotating oppositely at the moment of capture, the resulting ring inherits that backward motion, locking the system into eternal opposition. But here's where the mystery deepens. Simulations show this scenario should be incredibly rare. The angles and speeds required for such a perfect theft are absurdly precise. Even more baffling, NGC 4622's counter-rotating ring isn't just a thin, delicate structure. It's massive, packed with enough stars and gas to rival small galaxies, and it's been spinning backward for billions of years without disruption. Normally, friction between the ring and disk should have slowed the mismatch over time, yet this galaxy's war persists like a cosmic Cold War with no end in sight. The anomalies don't stop at motion. The backward ring glows with an unusual blue hue, a telltale sign of rampant star formation, while the inner disk burns redder, its stars aging quietly. This suggests the ring isn't just spinning backward, it's chemically distinct, almost like a foreign body grafted onto the galaxy. Some astronomers speculate the ring might be drawing fresh gas from intergalactic space, fueling its rebellious star birth while the original disk stagnates. Others wonder if dark matter is playing puppeteer, its invisible influence somehow propping up the ring's unnatural spin, the most startling discovery. In certain regions, the two opposing rotations create violent shock fronts where gas clouds collide head-on at millions of kilometers per hour. These cosmic traffic jams ignite supercharged stellar nurseries where stars form at rates 100 times faster than in our Milky Way. It's as though the galaxy's internal conflict isn't tearing it apart, it's forging something new, a stellar renaissance born from pure defiance. Yet for all its chaos, NGC 4622 isn't alone. At least a dozen similar backward spinning rings have been spotted, each challenging our assumptions in unique ways. One has a ring that flips direction halfway through, like a cosmic Möbius strip. Another shows the disk slowly tilting to match the ring's spin, as if surrendering to the rebellion. Whether these contradictions are cosmic accidents or signs of deeper, unseen forces, one thing's clear: the universe has a flair for drama, and ring galaxies are its most unpredictable performers. Every backward rotation isn't just a puzzle, it's a protest against the neat, orderly universe we thought we knew. At the heart of one particular ring galaxy, an impossible shadow looms, a darkness so vast it defies the very laws governing black holes. This cosmic anomaly, catalogued as NGC 3147, hosts a supermassive black hole whose shadow stretches across space like an oversized silhouette, dwarfing predictions based on its measured mass. Normally, a black hole's shadow, the absence of light created by its event horizon, should match calculations derived from its gravitational pull. But here, the darkness spans nearly twice the expected diameter, as though the universe itself has lost track of scale. What could cause such a discrepancy? One clue lies in the black hole's frenetic feeding habits. Observations reveal streams of gas spiraling into the void at unprecedented speeds, creating a whirling disk of superheated plasma that glows brighter than entire galaxies. This extreme environment might warp spacetime more severely than standard models predict, bending light outward in a way that magnifies the shadow's apparent size. Picture a funhouse mirror where the reflection isn't just distorted, it's stretched beyond recognition by forces we're only beginning to understand. Yet the plot thickens when you examine the shadow's edges. Instead of fading smoothly into the surrounding starlight, the darkness terminates in a series of jagged, thorn-like projections, as though something is physically tearing at the fabric of the event horizon. Radio telescopes have detected bizarre electromagnetic pulses emanating from these spikes, oscillating at frequencies that suggest violent vibrations in the black hole's very structure. Some theorists propose this could be evidence of a second, smaller black hole orbiting the primary, its gravity rippling the larger shadow like a stone disturbing a pond. Others speculate about quantum hair, hypothetical irregularities on a black hole's surface that could alter how it interacts with light, the most unsettling possibility. This shadow might not belong to the black hole alone. Gravitational wave detectors have noted faint tremors in spacetime around NGC 3147, hinting at an invisible companion, perhaps a dense knot of dark matter tangled in the black hole's gravitational field. If true, the combined gravitational influence could project a phantom shadow, a composite darkness larger than either object could cast alone. It's a cosmic sleight of hand where the unseen reshapes the visible, forcing us to question what we're really observing when we gaze into the abyss. What makes this oversized shadow more than just a curiosity is its eerie stability. Most black hole anomalies fluctuate as their accretion disks churn and change. Yet this shadow has maintained its exaggerated proportions for centuries, as recorded in historical observations dating back to early telescopic studies. Whether it's a flaw in our understanding of general relativity, a hidden celestial partnership, or something entirely unknown, one thing's certain: this ring galaxy's heart doesn't just hide a black hole. It guards a riddle written in negative space, a darkness that refuses to conform to the universe's rules. Some ring galaxies don't dance alone, they waltz with ghosts. Phantom companions, invisible partners whose presence is felt only through their gravitational pull, warp the delicate balance of these cosmic rings. Take the case of ring galaxy UGC 4599. Where the outer band of stars bulges and twists in ways that defy explanation unless you factor in an unseen heavyweight lurking just beyond the edge of visibility. These phantom partners aren't your typical cosmic suspects. They're not dim stars or cold gas clouds. The most compelling evidence points to rogue black holes, stellar outcasts wandering the void after being ejected from their home galaxies during violent collisions. One such candidate, hiding near the ring galaxy SDSSJ 0946, tugs on the ring with enough force to warp its shape into a teardrop, yet emits no light or radio waves. The only clue to its existence: stars at the galaxy's rim accelerate abruptly, as if yanked by an invisible leash, before settling back into their expected orbits. It's the gravitational equivalent of footsteps in an empty hallway. Something massive is there, but no matter how hard we stare, it refuses to show itself. But rogue black holes aren't the only invisible culprits. Some rings bear the fingerprints of dark matter clumps so dense they behave like celestial wrecking balls. In Galaxy AM0644, the ring's curvature kinks sharply in one section, as if pressed inward by an enormous, unseen thumb. Simulations suggest this dent could be the work of a dark matter subhalo, a knot of the universe's most elusive substance, drifting through the galaxy and bending its structure like a stone distorting a rubber sheet. Unlike black holes, these clumps leave no thermal signatures or lensing effects. their presence is betrayed solely by the way they rewrite the rules of motion for everything around them. The eerie part, some phantom companions seem to move independently of their host galaxies. Ring Galaxy NGC 2188 exhibits a distortion that migrates counterclockwise around its ring over centuries, as though its invisible partner is orbiting at a glacial pace. Normally, such massive objects would either merge with the galaxy or slingshot away entirely. Yet this one lingers, locked in a slow, silent dance that reshapes the ring over millennia. Astronomers have even nicknamed it the unseen conductor for the way it orchestrates stellar motions without ever taking the stage. Then there are the exceptions that upend all theories. In Galaxy ARP 147, gravitational anomalies suggest not one but two phantom companions, possibly a binary pair of rogue black holes or interacting dark matter halos, locked in a mutual orbit around the ring. Their combined pull creates a complex web of stellar currents, with streams of stars flowing in braided patterns that resemble celestial calligraphy. If confirmed, it would mark the first evidence of invisible systems lurking beyond the visible universe, rewriting the playbook on how dark structures evolve. Whether they are black holes, dark matter, or something beyond our current understanding, these phantom companions force us to confront a humbling truth. The cosmos is full of actors we cannot see, their presence revealed only through the subtle distortions they leave behind. Every warped ring, every unexplained stellar current is a whisper from the universe's hidden majority, an invitation to look deeper, to question not just what we see, but what we can't. Hidden among the chaos of colliding galaxies lies a cosmic chronometer unlike any other. A ring galaxy where the expanding band of stars races outward at exactly 299,792 kilometers per second. Not roughly, not approximately, but precisely the speed of light down to measurable decimal places. This freak of physics, catalogued as IC1059, behaves less like a galactic structure and more like a celestial clockwork, its growth rate mirroring the universe's ultimate speed limit with eerie perfection. At first glance, the galaxy's perfect symmetry suggests a violent past, a collision so perfectly centered it sent shockwaves pulsing outward like ripples in a pond. But here's the twist: those shockwaves didn't just spread randomly. They locked into a rhythm dictated by fundamental physics, expanding at the maximum speed spacetime allows. Every new star born in the wake of that expansion adds another tick to this cosmic clock, stretching the ring wider at a rate so constant, astronomers could theoretically use it to measure deep time across the universe. What makes this phenomenon stranger still is how it defies expectations. Galactic expansion typically slows over eons as gravity tugs back on fleeing matter. Yet IC1059's ring shows no sign of deceleration, its outward rush undimmed by the pull of dark matter or the galaxy's core. Some theorists propose the ring is surfing a wave of dark energy, the same mysterious force accelerating the universe's expansion, but localized to this single structure. Others point to the ring's unique composition. Vast clouds of ionized gas so finely tuned they behave like a superconductor, reducing drag to near zero and letting the expansion coast at light speed unimpeded. The most tantalizing possibility: this galaxy might be a natural particle accelerator. As the ring expands, simulations suggest it could generate shock fronts strong enough to sling charged particles to relativistic velocities, creating a self-sustaining feedback loop where the energy from those collisions further propels the ring's growth. It's a cosmic engine where the exhaust is the fuel, a runaway reaction that's somehow stabilized into perfect equilibrium. But the real magic lies in the implications. If the expansion holds steady, civilizations across the cosmos could theoretically synchronize their clocks by observing this galaxy's growth, a universal timekeeper written in starlight. Already, astronomers have used it to test relativity with unprecedented precision, confirming that light speed remains constant even across tens of thousands of light years. Every new star added to the ring isn't just another point of light. It's a second hand on the universe's grandest stopwatch, ticking forward in perfect lockstep with the laws that bind reality itself. Most galaxies shine with the soft glow of countless stars, but one stands apart, a celestial jewel box where the core doesn't just gleam, it scintillates. Meet the Diamond Ring Galaxy, a cosmic wonder designated as letter 9080, where the heart of the galaxy refracts light with such precision. It mimics the facets of a cut gemstone when viewed in ultraviolet and X-ray wavelengths. This isn't a poetic comparison. Telescope imagery reveals geometric patterns of light, sharp, edged, and prismatic, as if the galaxy's core were encased in a cosmic diamond. So what crafts this stellar jewel? The answer lies in an impossibly dense stellar metropolis at the galaxy's center. While most galactic cores host a loose sprawl of aging stars or a supermassive black hole, this one crams millions of stars into a volume smaller than our solar system. The crowding is so extreme that stellar orbits intersect like a knotted ball of string, creating a gravitational pressure cooker where collisions are constant. Every impact shatters stars, spewing clouds of crystallized carbon real diamond dust into the surrounding void. Over eons, these microscopic diamonds accumulate into vast orbital bands, their facets aligned by the galaxy's powerful magnetic fields. When high-energy light from nearby quasars strikes these bands, the result is a literal cosmic sparkle, with refracted light bursting outward in geometric patterns unseen anywhere else in nature. But the true marvel isn't just the bling, it's the timing. This galaxy's diamond-like glint pulses rhythmically, brightening every 72 years like clockwork. Astronomers trace these pulses to a pair of tightly orbiting neutron stars at the core, whose gravity stirs the diamond clouds like a spoon swirling glitter in water. As the neutron stars eclipse each other, their gravitational wobble compresses the dust lanes, momentarily enhancing their reflective properties. It's a celestial strobe light forged by precision and chaos, where the universe's most violent objects conspire to create something achingly beautiful. The Diamond Ring Galaxy's brilliance isn't just visual, it's acoustic. Radio telescopes have detected something even stranger. The crystallized carbon rings vibrate in response to gravitational waves, emitting faint, resonant tones at frequencies matching the theoretical ringing of diamond crystals under stress. Converted to sound, these frequencies form a haunting, bell-like chord that repeats with each rotational cycle of the neutron star duo. It's as though the galaxy isn't just a jewel, it's a cosmic music box playing a melody written in space-time itself. Yet for all its splendor, this galaxy holds a darker secret. The same forces that create its sparkle are also tearing it apart. Spectral analysis reveals the diamond bands are laced with exotic matter, particles that decay unpredictably, emitting antimatter bursts that erode the surrounding structure. Every glittering pulse may be a farewell performance, a slow-motion disintegration of one of the universe's rarest masterpieces. Whether it's destined to fade into darkness or transform into something even stranger, the Diamond Ring Galaxy reminds us that even in the cold void of space, beauty persists, not despite the chaos, but because of it. Most galaxies radiate heat predictably, stars warm their surroundings, black holes emit fiery accretion disks, and cosmic dust glows with residual warmth. But one ring galaxy breaks all the rules, its outer band blazing with heat so intense it outshines the core despite having no visible power source. Meet the Ring of Fire, a celestial paradox catalogued as UGC 3672, where thermal telescopes reveal infrared radiation equivalent to 100 billion suns pouring from its ring, yet optical scans show barely enough stars to explain a fraction of that energy. It's like stumbling upon a bonfire in the Arctic. No fuel, no spark, just relentless, unexplained heat. The mystery begins with the ring's composition. Unlike typical star-forming regions where young, massive stars pump out radiation, this ring is eerily sparse. The handful of visible stars are small and cool, red dwarfs utterly incapable of generating the observed heat. Even more baffling, the thermal emission isn't evenly distributed. It clusters in discrete, superheated knots spaced along the ring like beads on a necklace, each radiating at temperatures exceeding 3000 Kelvin hotter than some stellar surfaces. When astronomers trained spectroscopes on these knots, expecting to find hidden stellar nurseries or black holes, they got silence. No X-rays, no ultraviolet flares, just a smooth, featureless thermal curve that defies all known astrophysical processes. One radical theory suggests we're witnessing dark matter annihilation on an unprecedented scale. If certain hypothetical particles like weakly interacting massive particles or WIMP collide and decay within the ring's gravity well, they could release pure thermal energy without the usual electromagnetic byproducts. It's a cosmic stealth furnace burning fuel we can't see. Supporting this idea, the ring's gravitational field shows subtle anomalies with pockets of mass that don't correspond to any visible matter. Yet even this exotic explanation falters when confronted with the heat's precision. The knots maintain their temperature with less than 1% variation over decades, as if regulated by some unseen thermostat. Then there's the galaxy's eerie silence. Most high-energy systems, quasars, pulsars, supernova remnants crackle with radio noise or gamma-ray bursts, but the Ring of Fire emits nothing except infrared. It's a cosmic blackbody radiator, the kind physicists create in labs to study pure thermal dynamics, except scaled up to galactic proportions. Some researchers propose the heat might originate from a network of microscopic primordial black holes, their Hawking radiation blending into a smooth thermal haze. Others wonder if the ring is a cosmic mirage, an illusion caused by space-time curvature focusing heat from a distant, hidden source, the most unsettling clue. The ring's heat pattern rotates around the galaxy at a rate that doesn't match the stars or gas. Whatever's generating the energy moves independently, drifting clockwise like a ghostly second hand on a celestial clock. Every hypothesis runs aground on this observation. Dark matter shouldn't behave this way. Black holes would leave traces. Even the most exotic physics can't easily explain a self-contained, roving heat source of this magnitude. And then there's the kicker: historical records show the ring wasn't always this hot. 19th century plate archives reveal a faint, cool structure. Sometime in the early 20th century, the temperatures spiked abruptly as though someone or something flipped a switch. Whether it's an undiscovered astrophysical phenomenon or something beyond our current science, the Ring of Fire stands as a searing enigma, a cosmic contradiction where heat defies its own source. Every infrared photon carries a question. In a universe governed by cause and effect, how does a galaxy burn without fuel? Hidden in the starlight of certain ring galaxies are spectral lines that shouldn't exist, fingerprints of elements unknown to science, scribbled across the cosmos like cosmic graffiti. These unidentified emission lines appear as spikes and dips in the rainbow of light split by telescopes, marking wavelengths where no known atom or molecule should absorb or emit energy. Three galaxies, UGC 5597, LEDA 12496 and ARP 224, stand out as the most perplexing, each displaying spectral anomalies so consistent they've sparked a firestorm of debate. Are we glimpsing exotic matter, flaws in our quantum models, or something even stranger? Take UGC 5597 first. Its spectrum shows a cluster of sharp lines near the ultraviolet range, perfectly spaced like rungs on a ladder, a pattern that matches no known atomic transition. At first, astronomers dismissed it as instrumental error, but when every telescope from Hubble to the Very Large Telescope confirmed the same pattern, the mystery deepened. The lines don't shift with the galaxy's rotation, meaning they're not tied to any moving gas cloud. Instead, they're fixed, as if etched into space-time itself. One radical theory suggests these could be signatures of hexaquarks, hypothetical particles made of 6 quarks bound together in ways ordinary matter can't replicate. If true, they might form stable quark stars within the ring, radiating energy along these exact wavelengths. Then there's letter 12496, home to a single, monstrous emission line in the infrared, a spike so intense it drowns out everything around it. This isn't just an anomaly, it's a spectral siren blaring at a frequency that corresponds to no known element or chemical compound, the most tantalizing clue. The line's width suggests the emitting material is under unimaginable pressure, far beyond what neutron stars or black hole accretion disks produce. Some researchers propose it's evidence of quantum nuclear matter, a state where protons and neutrons dissolve into a soup of quarks and gluons, creating light unlike anything in our periodic table. Others wonder if we're seeing the decay of primordial dark matter particles, their annihilation emitting energy at this precise wavelength. ARP-224, the third enigma, flaunts a series of faint, flickering lines that vanish and reappear over decades. Unlike the steady signals of normal elements, these lines pulse erratically, fading for years before flaring back to life. The strangest detail, they're redshifted but not uniformly. Some lines suggest the source is receding at 15% the speed of light, others at 30%, as though the galaxy harbors multiple invisible objects racing away in different directions. One daring hypothesis posits mirror matter, a shadowy counterpart to normal particles that interacts only weakly with our universe. If clumps of this mirror stuff orbit the galaxy, their rare interactions with ordinary matter might release these sporadic bursts of light. The implications stretch beyond astronomy. If these lines confirm new states of matter, they could rewrite particle physics. If they're tied to dark matter, they might unveil the universe's missing mass. And if there's something else entirely, well, that's the thrill. Every unexplained line is a cipher, a coded message from the cosmos waiting for its Rosetta Stone. Until then, these galaxies remain cosmic rebels, flaunting spectral graffiti that defies our understanding, one mysterious wavelength at a time. Deep in the cosmic tapestry, there's a ring galaxy that defies the inevitable decay of the universe, a celestial structure that doesn't just endure damage but actively repairs it. Meet the self-healing galaxy, officially catalogued as NGC 5705, where gaps torn by gravitational disruptions don't linger as cosmic scars. Instead, they stitch themselves back together over centuries, as if the galaxy possesses some unseen regenerative power. At first glance, this phenomenon seems impossible. Galactic rings are delicate structures, their shapes dictated by the unforgiving laws of gravity and momentum. When a passing star cluster or dark matter clump tears a hole in the ring, the disruption should persist for millions of years. Yet in NGC 5705, telescopes have documented at least 3 major gaps, each spanning hundreds of light years, that visibly shrink over decades, filling in with fresh stars and gas as though guided by an invisible hand. The healing process follows a bizarrely methodical pattern. First, tendrils of hydrogen gas stretch across the void, forming delicate bridges between the severed edges of the ring. Next, these filaments thicken, pulling stars from neighboring regions into the gap like cosmic stitches. Finally, new stellar nurseries ignite along these seams, their blue-white glow erasing all traces of the injury. The entire process resembles time-lapse footage of a wound closing, except the wound is 1,000 light-years wide, and the healer is a force we've yet to name. One possible explanation involves dark matter vortices, swirling currents of invisible mass that act like cosmic looms, weaving disrupted regions back into coherence. Radio telescopes have detected strange, coherent motions in the galaxy's outer halo, suggesting hidden structures funneling material into the gaps. Another theory points to the galaxy's unusually strong magnetic fields, which might organize scattered gas into orderly streams, accelerating the repair process. But the most tantalizing clue lies in the stars themselves. Spectroscopic analysis reveals that the new stars appearing in healed gaps aren't actually young. They're ancient stars that have been chemically rejuvenated, their outer layers enriched with fresh hydrogen, as if something stripped away their aged atmospheres and replaced them with pristine fuel. This discovery appends stellar life cycle models, hinting at a galactic-scale recycling mechanism we've never observed elsewhere. The implications are staggering. If galaxies can actively repair themselves, our entire understanding of cosmic evolution might need rewriting. Collisions and disruptions wouldn't just be destructive events, they'd be catalysts for renewal, part of a hidden cycle of cosmic healing. Every closing gap in NGC 5705 isn't just a curiosity. It's a challenge to the very idea that the universe only winds down. Sometimes, against all odds, it stitches itself back together. At the heart of one particular ring galaxy, nature has sculpted a structure so violently beautiful it could only be described as a cosmic tornado, a spiraling jet of stellar materials stretching tens of thousands of light years from the galaxy's core, twisting space itself into a whirlpool of destruction and creation. This isn't just a galactic feature, it's a full-blown celestial vortex, a maelstrom of gas, dust, and stars churning with forces that defy imagination. What makes this phenomenon so extraordinary isn't just its scale, it's the sheer precision of the spiral. Unlike the chaotic jets seen in active galaxies, this one coils outward in a near-perfect helix, like a strand of DNA unraveled across the cosmos. The jet structure suggests something far stranger than random turbulence at work. Magnetic fields, trillions of times stronger than Earth's, appear to guide every loop and curve, threading the ejected material into this eerie cosmic braid. The origin of this vortex lies in the galaxy's violent past, a collision so perfectly angled it didn't just form a ring, it sent the galaxy's core into a hyperactive spin. As the supermassive black hole at the center whirled faster, its accretion disk warped into a spinning platter, launching material outward not in straight bursts but in this tightly wound spiral. Think of water spiraling down a drain, except here the drain is a black hole and the water is superheated plasma moving at nearly the speed of light. But here's where the mystery deepens. The jet doesn't just spew material aimlessly into space, it pumps it directly back into the galaxy's outer ring. Observations reveal streams of enriched gas, heavy with elements forged in stellar explosions, flowing along the spiral's curves before raining down onto the ring like cosmic fertilizer. This creates a self-sustaining cycle where the galaxy's core devours matter, expels it in a controlled vortex, and then recycles it to birth new stars. It's a feedback loop of stellar life and death, orchestrated with unnatural precision. Even more bizarre is the jet's rhythmic behavior. Unlike most galactic outflows, which fluctuate unpredictably, this one pulses in a steady cadence, brightening, dimming, and brightening again every 47 years like clockwork. Some astronomers speculate this could be caused by a second, smaller black hole orbiting the primary, its gravity tugging the jet like a child spinning a garden hose, creating regular waves in the outflow. Others suggest the jet itself might be generating standing waves, a sort of cosmic resonance that keeps the spiral locked in this perfect, undulating motion. The most haunting detail, the tornado isn't static, it's growing. Measurements spanning decades show the spiral gradually widening, its coils stretching farther into intergalactic space with each passing millennium. Where this expansion will end, or whether it will eventually destabilize the galaxy entirely, remains one of the universe's most mesmerizing unanswered questions. One thing's certain, this isn't just a jet, it's a cosmic architect reshaping its galaxy one whirl at a time. Most galaxies hold their shape with rigid permanence, their structures locked in by gravity's unyielding grip, but not this one. Picture a celestial band of stars that refuses to stay still, a ring galaxy where the entire structure pulses rhythmically, expanding and contracting like the chest of some cosmic giant taking slow, deliberate breaths. This is the phenomenon astronomers have poetically dubbed the breathing ring, a galaxy designated as UGC 12112, where the outer band of stars doesn't just spin, it swells and shrinks by nearly 15% over a 54-year cycle, defying everything we know about galactic stability. The rhythm is uncanny. Every 27 years, the ring expands outward at a steady 70,000 kilometers per hour, stretching the galaxy's luminous edge farther into the void. Then, as if hitting some invisible barrier, it reverses course, drawing back inward at the same measured pace. Time-lapse observations spanning decades reveal this motion with startling clarity, not a chaotic wobble, but a smooth, sinusoidal oscillation that could be plotted on a graph like the vital signs of a living organism. What makes this breathing motion even stranger is its precision. Unlike the erratic flickering of unstable galaxies, these pulsations are metronomic, their timing consistent across centuries of historical records. So what force could possibly set an entire galaxy breathing? One leading theory involves a dance of dark matter. Simulations suggest the galaxy might be embedded in a spinning halo of dark matter, an invisible cosmic whirlpool whose gravitational tides alternately pull the ring outward, then release it like a slingshot. Think of a hula hoop twirling around a dancer's waist. As the unseen mass rotates, its shifting gravity tugs the ring of stars into this rhythmic expansion and contraction. But here's the catch: the dark matter halo would need to be asymmetrical, denser on one side than the other, to create the necessary tidal forces. And that raises another question: what could sculpt dark matter into such an unnatural shape? Yet the dark matter explanation isn't the only contender. Some astronomers point to the galaxy's peculiar core, home to not one but two supermassive black holes locked in a tight orbital embrace. As these titans spiral around each other, their gravitational push and pull might send waves rippling through the galaxy's disk, alternately compressing and stretching the outer ring like an accordion. The timing fits: the black hole's estimated orbital period aligns neatly with the galaxy's breathing cycle. But this scenario comes with its own paradox. Binary black holes typically inject chaos into their surroundings, not clockwork regularity. For this theory to hold, the pair would need to orbit with freakish precision, their movements fine-tuned to avoid disrupting the larger pattern. Then there's the star formation mystery. Most galaxies form new stars in fits and starts, but the breathing ring's stellar nurseries ignite in perfect sync with its pulsations. As the ring expands, telescopes detect a surge of newborn stars along its outer edge, their blue-hot light flaring like fireflies at the peak of an inhalation. When the ring contracts, these regions dim, as if the galaxy is holding its breath. Somehow, the physical motion of the ring itself seems to be triggering star birth, a feedback loop where expansion compresses gas clouds just enough to spark ignition, while contraction stifles the process. It's a celestial lung that doesn't just move, but breathes life into new stars with every cycle. The most haunting possibility: we might be witnessing a galaxy caught in the act of metamorphosis. Some models suggest the breathing ring could be transitioning from a classic collisional ring into a rare polar ring galaxy, its oscillations marking the slow, deliberate realignment of its entire structure. If true, we're catching a process that usually unfolds over millennia in a bizarrely accelerated form, a cosmic butterfly mid-transformation, its wings still trembling as they take shape. Every pulse could be a step toward a new identity, a reminder that even the grandest structures in the universe are never truly static, only changing too slowly for us to notice. Until we unravel its secrets, the breathing ring stands as a cosmic metronome, ticking off the decades with the patience of eternity. Whether it's dark matter's hidden hand, dueling black holes, or some deeper physics we've yet to grasp, one thing's certain: this galaxy doesn't just exist. It lives, Some galaxies don't just spin in isolation, they become cosmic landmarks, aligning with distant quasars in formations so precise they border on the impossible. Enter the phenomenon astronomers call the impossible alignment, where a ring galaxy positions itself like a bullseye in a celestial archery range, its center perfectly lined up with not one, but multiple quasars billions of light-years behind it. The odds of such an arrangement occurring by chance, statistically negligible, like tossing a handful of confetti into the wind and watching every piece land in a straight line spanning continents. Take the case of ring galaxy SSJ 0826 plus 2233, where the core sits at the exact midpoint of a chain of 4 quasars, each one a searing beacon from a different epoch of the universe's history. These quasars aren't just randomly scattered, they're spaced at near-perfect intervals, forming a ruler straight line that pierces the galaxy's heart. From our vantage point, the alignment is so flawless that the quasars appear to orbit the ring like planets around a star, even though they're separated by unimaginable distances. The furthest quasar in the sequence lies a staggering 12 billion light-years away, meaning its light began its journey when the universe was barely a toddler, yet it still lines up with galactic precision. What could orchestrate such a cosmic coincidence? One theory suggests the galaxy and quasars might be threaded along a titanic filament of dark matter, an invisible highway stretching across the cosmos, its gravity funneling matter into these precise positions over eons. Simulations show dark matter forms a web-like structure throughout the universe, with dense knots where galaxies cluster. If this ring galaxy and the quasars all settled onto the same dark matter thread, their alignment might not be entirely random, just extraordinarily rare. But there's a catch. The quasars aren't just aligned spatially. Their light shows eerily similar spectral distortions, as though something between them and us is bending their light identically. This points to another possibility, an unseen gravitational lens, perhaps a primordial black hole or a clump of exotic matter, warping spacetime along our line of sight and creating the illusion of alignment. Yet even this explanation falters when confronted with the scale. For a lens to perfectly align multiple quasars across such vast distances, it would need mass and symmetry beyond anything we've observed. The most radical idea, we're seeing a fingerprint of something deeper, a fundamental symmetry or structure woven into the fabric of the universe itself. Some theorists propose these alignments could be signatures of cosmic defects, relics from the Big Bang where spacetime itself is subtly warped, guiding light and matter into unnatural formations. Others speculate about quantum entanglement on a scale so vast it defies intuition, linking these objects across time and space in ways physics can't yet describe. What makes this alignment more than just a curiosity is its defiance of time. The quasar's light arrives from vastly different epochs, one from the universe's first billion years, another from its middle age, yet they now share this geometric harmony. It's like finding ancient cities on Earth built in a perfect line, each constructed millennia apart by civilizations unaware of the others. Whether it's a statistical fluke, an unseen cosmic scaffold, or evidence of deeper laws waiting to be uncovered, one thing's certain: the universe has a flair for arranging its mysteries in plain sight, daring us to connect the dots. Every perfect alignment is a whisper, a hint that chaos might not reign supreme, and that somewhere, hidden in the vastness, order persists in ways we're only beginning to imagine. Most ring galaxies appear smooth and uniform when viewed from afar, but look closer and some reveal ghostly secrets. Faint radial spokes stretch across their starry bands like cracks in a cosmic windshield, these whisper-thin structures defying the neat symmetry of their host rings. Known simply as the spokes, these ephemeral features don't glow with the brilliance of young stars or the heat of stellar nurseries. Instead, they linger as subtle scars, visible only through careful observation and advanced filtering techniques that tease their dim signatures from the background glow of the galaxy. What could create such delicate yet enduring structures? The leading theory points to ancient violence, cataclysmic collisions where smaller galaxies plowed through the heart of a larger one, sending shockwaves rippling outward. Imagine tossing a stone into a pond, but instead of clean circular waves, the impact creates straight, radiating lines. In galactic terms, these shock fronts might have compressed gas and dust into narrow spokes, leaving behind permanent etchings in the ring's structure. Some of the most prominent examples, like the spokes in Galaxy AM0644, align eerily with neighboring dwarf galaxies, as if these smaller objects left their calling cards in the rings they once disrupted. Yet there's a problem with this explanation. Many spokes show no trace of a culprit, no nearby galaxies, no debris trails, just the faint radial lines, stubbornly persisting as if painted onto the cosmos by an invisible hand. This has led to more exotic theories, including the possibility of dark matter tendrils. If dark matter forms filaments that stretch across the universe, as some models suggest, these invisible strands might have brushed through the ring galaxy, their gravity subtly rearranging stars and gas into these linear patterns. Supporting this idea, certain spokes coincide with regions where the galaxy's rotation curves suggest unexpected gravitational tugs, as though unseen masses are anchored along these ghostly lines. The real enigma lies in the spoke's longevity. These structures should dissipate over time, smeared into oblivion by the galaxy's rotation. Instead, some have endured for billions of years, their shapes barely distorted. It's as though the galaxy itself remembers the event that created them, locking the pattern into place with some unseen cosmic adhesive. A handful of spokes even show signs of recent activity, gaps where new stars refuse to form, or filaments of ionized gas that flicker like neon signs along their length. Could magnetic fields be reinforcing these structures, acting like cosmic wires that channel energy along fixed paths? Or are we seeing the aftermath of a phenomenon we've yet to name, where spacetime itself retains the memory of ancient disturbances? The most haunting spokes are those that flicker in and out of visibility. In Galaxy NGC 4622, astronomers have documented radial features that appear in ultraviolet light but vanish in optical wavelengths, as though they're made of some material that only interacts with specific energies. Others, like the phantom spokes of UGC 9701, only reveal themselves when viewed through polarized filters, their light twisted into alignment by forces we can't yet measure. These elusive structures hint at a deeper complexity, where the universe's hidden layers occasionally bleed into the visible spectrum, offering fleeting glimpses of the scaffolding behind reality. Every spoke is a riddle wrapped in starlight, a clue to collisions we didn't witness, forces we can't yet detect, or physics we're only beginning to unravel. Whether they are scars from long-dead intruders, highways for dark matter, or something even more mysterious, one thing's certain: these faint radial veins are more than just decoration. They're the galaxy's way of whispering its secrets, if only we know how to listen. Two galaxies stand apart in a way that twists our understanding of reality itself. Cosmic structures where the rules of three-dimensional space seem to fray at the edges. Known collectively as dimensional anomalies, these ring galaxies NGC 8889 and letter 72006 display behaviors that some scientists argue can only be explained by influences from dimensions beyond our own. Take NGC 8889 first. At a glance, its ring appears normal, but closer inspection reveals star clusters that vanish and reappear in different locations when observed in specific wavelengths. These aren't just gaps in visibility. The star's spectral signatures shift as though they're briefly slipping out of our dimensional plane before snapping back into place. Even stranger, the galaxy's magnetic field forms geometric patterns, perfect tetrahedrons and dodecahedrons, that align with theoretical models of higher dimensional objects casting shadows into our universe. It's as if we're seeing the imprint of a four-dimensional structure pressing into the fabric of familiar spacetime. Then there's letter 72006, where the ring itself seems to exist in multiple states simultaneously. Radio telescopes detect faint echoes of the galaxy's structure overlapping itself at slight angles like a cosmic double exposure. These ghostly duplicates aren't gravitational lensing effects, they persist even when accounting for all known matter. Some researchers propose this could be evidence of a brain collision, where membranes of higher dimensional space briefly intersect, allowing the galaxy to occupy two positions at once. The most baffling detail, these echoes pulse in sync with gamma-ray bursts from the galaxy's core, as though whatever's causing the dimensional overlap is also powering the black hole's eruptions. Theories abound, from string theory's hidden dimensions to quantum foam bubbling up into macroscopic reality. But one thing's certain, these galaxies aren't just challenging our maps of the cosmos, they're hinting that the universe's full blueprint might be written in dimensions we're only beginning to sense. Every anomalous star cluster, every impossible geometric field, is a breadcrumb trail leading beyond the edges of known physics. At first glance, there's nothing unusual about ring galaxy PGC 04576 until you focus on the band of stars that should be its most luminous feature. Instead of glowing with the warmth of billions of suns, the ring is colder than the void between galaxies, swallowing every photon that dares to touch it. This isn't just a dusty nebula or a shadowy void, it's a cosmic abyss so absolute that astronomers have dubbed it the Ring of Darkness, a structure that absorbs 100% of incoming light across every wavelength from radio to gamma rays. Even black holes, the universe's textbook light eaters, can't match this level of pure oblivion, radiating at least some energy as Hawking radiation or through their accretion disks. But here, the ring offers no such consolation. It's a perfect annulus of nothingness, a hole punched through reality itself. What could possibly explain such an extreme phenomenon? The leading theory involves a freakish alignment of cosmic conditions. Imagine the ring as a celestial prison for light, an expanse of space where dust clouds don't just dim starlight but trap it eternally. These aren't ordinary interstellar particles, they're theorized to be perfect absorbers, a hypothetical form of matter with atomic structures tuned to capture photons without re-emitting them. Under normal circumstances, even the densest dust scatters some light, but here, the particles might be arranged in fractal patterns so intricate they create infinite pathways for light to wander until its energy dissipates entirely. It's like a maze with no exit where every turn leads deeper into darkness, but the mystery deepens when you consider the ring's gravitational signature. Most light-absorbing regions like Bok globules or dark nebulae have detectable mass. The Ring of Darkness defies this expectation. Measurements suggest its gravitational pull is weaker than expected for something so opaque, as though whatever's blocking the light isn't fully anchored to our universe. Some researchers speculate this could be evidence of a brain shadow, where a higher dimensional object intersects our three-dimensional space, casting a perfectly dark silhouette. Others propose an exotic quantum effect where the ring's particles exist in a superpositional state that cancels out light's wave function entirely, effectively erasing photons from existence. Then there's the eerie silence. Most cosmic voids emit at least faint whispers of background radiation. Not this one. Radio telescopes aimed at the ring pick up nothing not static, not echoes of the Big Bang, just pure, unbroken silence. It's as if the region has been acoustically insulated from the rest of the universe. Even stranger, the boundary between the ring and normal space is razor-sharp with no transitional zone. Stars on one side blaze brightly, those a fraction of a light year away vanish as though snipped from the sky with cosmic scissors, the most unsettling clue. The ring isn't static. Over decades of observation, its edges have crept outward, swallowing neighboring stars at a rate that defies known physics. Normally, Such expansion would require unimaginable energy, yet the ring grows without emitting any detectable radiation or gravitational waves. It's a paradox, a structure that consumes light yet leaves no trace of its feast. Whether it's a window into undiscovered physics, a collision with an alien dimension, or something even more unfathomable, the Ring of Darkness stands as a cosmic riddle wrapped in perfect black. Every photon it devours is a question mark, a silent challenge to our understanding of how light, matter, and reality itself are supposed to behave. Separated by nearly 250 million light-years, a distance so vast light itself would take 250 million years to cross. Two ring galaxies defy every law of cosmic isolation. NGC 7319 and its counterpart UGC 12108 exhibit changes that synchronize perfectly despite the impossibility of any signal traveling between them fast enough to explain the connection. When star-forming regions flare up in one galaxy's ring, identical flares ignite in the same configuration in the other within days, sometimes hours. Not just roughly similar, precisely mirrored, down to the number of new stars and their chemical signatures. It's as if these galaxies share a single consciousness, reacting to stimuli we can't perceive across distances relativity says should make instant communication impossible. The phenomenon becomes even stranger when examining their magnetic fields. Radio telescope data reveals fluctuations in NGC 7319's polarization patterns that appear in UGC 12108 spectra at the same observational moment, despite the time delay their separation should impose. This isn't just a case of parallel evolution, it's a real-time cosmic synchronization that suggests some form of quantum entanglement operating on a galactic scale. Normally, quantum links only persist between subatomic particles and dissolve when scaled up to macroscopic objects. Yet here, billions of stars move in lockstep, their collective behavior entwined like electrons in a paired spin state. What could forge such a connection? One theory points to a shared origin, a single primordial structure that split during the universe's inflationary period, carrying correlated quantum states into two distant patches of space. If certain properties were entangled before this cosmic divorce, their evolution might remain linked regardless of separation. Another idea involves higher dimensional physics, where the galaxy's rings intersect in unseen dimensions, allowing changes to propagate outside our conventional spacetime. The most radical proposal: these galaxies might be projections of a single object, their apparent separation an illusion caused by spacetime's geometry folding back on itself like a Möbius strip viewed edge-on. The most unsettling evidence comes from their central black holes. Both galaxies host supermassive voids of nearly identical mass, and their accretion disks brighten and dim in perfect unison, even when one black hole should be obscured by dust clouds that ought to block its emissions from our view. It's as if the black holes aren't just communicating but are in some fundamental sense the same object, their event horizons threaded together through hidden cosmic fabric. Every flicker, every outburst challenges our understanding of locality, causality, and the very nature of separation in the cosmos. Yet for all their synchronicity, these twins aren't perfect clones. Subtle differences emerge at their edges, regions where star formation lags slightly behind or magnetic field lines kink in opposite directions. These asymmetries hint that entanglement, if that's truly what we're witnessing, might degrade over cosmic distances or interact unpredictably with local conditions. They're reminders that even the universe's most uncanny connections leave room for individuality, threads in a tapestry far more complex than we've yet imagined. Whether it's quantum weirdness scaled to galactic proportions or evidence of physics beyond our models, one thing's certain: when two galaxies dance to the same rhythm across an ocean of nothingness, the universe is whispering secrets we're only beginning to hear. Buried within the swirling arms of the ring galaxy NGC 4217 lies a cosmic contradiction that rewrites the timeline of galactic evolution, a band of ancient stars so old they predate the galaxy itself, encircling younger stellar populations like a celestial grandfather clock embedded in a modern cityscape. This isn't just a minor age gap. Spectral analysis reveals stars in the ring burning with the faint, red glow of advanced age, their atmospheres laced with heavy elements at concentrations typical of the universe's first stellar generation. Meanwhile, the galaxy's core and surrounding disk sparkle with relatively youthful stars, their blue-white light betraying a birth date billions of years after their ringed elders. How does a galaxy end up wearing its ancestors like a belt? The leading theory involves a galactic near-death experience. Billions of years ago, NGC 4217 may have been a normal spiral until a cataclysmic collision stripped away its outer disk, leaving only the ancient central bulge intact. As intergalactic gas slowly seeped back into the ravaged core, fresh stars ignited, but the original ring of primordial stars survived the devastation, preserved like a fossilized imprint of the galaxy's violent past. Imagine a tree whose inner rings are younger than its bark, and you begin to grasp the temporal inversion at play here. Yet the real mystery lies in the ring's impossible stability. Ancient stars typically migrate inward over time, drawn by gravitational interactions with denser central regions. These relics, however, cling stubbornly to their orbital path, defying simulations that predict their dispersal. Some researchers suggest the ring might be anchored by an invisible scaffold of dark matter, a relic halo frozen in the configuration of the galaxy's earliest days. Others propose more exotic explanations, like modified gravity effects that strengthen with stellar age, effectively creating a senior citizen's lane where older stars resist orbital decay. The most startling clue comes from stellar archaeology. Spectra of the fossil rings stars reveal patterns of elemental enrichment that don't match any known galactic region. They're missing certain isotopes common in ancient stars elsewhere, as if they formed in isolation from the normal chemical evolution of the cosmos. One provocative interpretation. These stars might be refugees from an entirely different galaxy, one that dissolved during the collision, leaving only its oldest, most resilient members behind as a ghostly reminder. What makes NGC 4217 truly exceptional is how its fossil ring interacts with the present-day galaxy. In most systems, ancient stars are passive relics, but here they actively shape their environment. Their collective gravity corrals streams of inflowing gas, funneling it into precise locations where new stars ignite, effectively using their antiquity to midwife the next generation. It's a cosmic irony. The oldest structures in this galaxy have become the architects of its future, their silent orbits writing prescriptions for stellar birth long after their own fires first ignited. Whether it's a preserved remnant of galactic infancy or the graveyard of a long-dead neighbor, this fossil ring stands as a celestial time capsule, holding secrets about how galaxies weather cosmic violence and rebuild themselves across eons. Every ancient star in its band is a witness to epochs we can only simulate, their light carrying stories of a universe far stranger than we ever imagined. Somewhere in the vast expanse of space, a ring galaxy glows with colors the human eye can't process, hues that exist outside the traditional rainbow, invisible to every optical telescope yet blazing unmistakably in specialized instruments. This is the phenomenon astronomers call forbidden color, a cosmic palette so bizarre it defies the very physics of light. In Galaxy SDSS J0943, vast swaths of the ring emit wavelengths that straddle the boundary between ultraviolet and X-ray radiation, a spectral range so extreme it's typically absorbed by Earth's atmosphere before reaching our eyes. But when viewed through space-based observatories equipped with multi-spectral sensors, the galaxy reveals a shimmering turquoise-lavender hybrid, a hue with no name because it's never been observed naturally anywhere else in the universe. What creates these impossible shades? The culprit lies in the galaxy's turbulent core, where a supermassive black hole's jets bombard the surrounding ring with particles moving at nearly the speed of light. When these high-energy particles collide with the ring's gas clouds, they excite electrons to energy states so unstable, conventional atomic physics says they should collapse instantly without emitting light. Yet here, they persist just long enough to release photons in transitional wavelength color, producing interactions that standard quantum models classify as forbidden. It's like catching lightning in a bottle, then discovering the lightning glows in a shade that doesn't belong on any color wheel. Even stranger, these hues shift depending on the observer's relative motion. To a hypothetical traveler approaching the galaxy at relativistic speeds, the forbidden colors would appear to slide across the spectrum, blending into yellows and pinks that are equally unattainable under normal stellar conditions. This relativistic color drift suggests the phenomenon isn't just about the light itself, but how space-time warps around the galaxy's ultra-dense core, stretching and compressing wavelengths in ways that create chromatic illusions. The most unsettling discovery: certain segments of the ring absorb light rather than emit it, but only at very specific, non-colors. Instruments have detected pitch-black bands where the galaxy devours every photon except those matching precise, unnameable wavelengths, leaving behind voids that act like cosmic roach traps for undesirable light. It's as if the galaxy has curated its own electromagnetic menu, accepting only the most exotic frequencies while rejecting the rest. Whether it's a quirk of extreme physics or a window into undiscovered quantum behaviors, one thing's certain: this galaxy doesn't just defy our expectations of color. It rewrites them, painting the cosmos in shades we lack the vocabulary to describe. Every impossible hue is a reminder the universe's palette is far richer than we've ever dreamed. Picture a galactic structure so bizarre it resembles a hovering crown, a perfect ring of stars and gas suspended in space, utterly disconnected from any visible core or central galaxy. This is the phenomenon astronomers have dubbed the floating ring, a celestial oddity that defies one of the universe's most fundamental forces, gravity. In most ring galaxies, the luminous band orbits a dense central hub, held in place by the predictable tug of a supermassive black hole or stellar cluster. But here, in the case of SDSS J1420, the ring drifts alone, a cosmic donut with no hole, its trillion stars circling nothing. The mystery begins with the ring's motion. Spectroscopic observations reveal the entire structure rotates at speeds that should send it flying apart, unless something invisible anchors it. Calculations show the star's velocity demands nearly 10 times more mass than what telescopes can detect. Yet, unlike typical dark matter scenarios where unseen halos surround visible galaxies, this missing mass seems concentrated in an empty region at the ring's geometric center. It's as though an invisible giant grips the ring by its middle, counteracting centrifugal force with perfect precision. One theory suggests a ghostly black hole collision might be to blame. If two supermassive black holes merged and ejected their combined behemoth through gravitational wave recoil, the departing black hole could have stripped away the galaxy's core entirely, leaving only the outer ring behind. But here's the catch: the ring shows no signs of distortion from such a violent exit. No warped stellar streams, no ripples in the gas. Instead, its symmetry is flawless, as if the core didn't flee but vanished, leaving behind only its gravitational shadow. Even stranger are the ring's gravitational microlensing effects. When background stars pass behind it, their light bends not just around the ring's edges but through its empty center, as if space itself warps around an unseen focal point. Some researchers propose this could be evidence of a naked singularity, a black hole without an event horizon, its infinite density exposed to the universe. Others speculate about exotic objects like gravastars, theoretical constructs where vacuum energy replaces the central singularity, creating a gravitational imprint without a physical anchor. Then there's the eerie stability of the structure. Most orphaned rings should dissipate within a few 100 million years as stellar motions randomize. Yet this one has persisted for billions of years, its stars locked into synchronized orbits with no visible conductor. Radio telescopes have detected faint, rhythmic pulses emanating from the ring's void, not electromagnetic waves but perturbations in spacetime itself, vibrating at frequencies that suggest something massive oscillates invisibly at the heart of nothingness. Whether it's a black hole dressed in cosmic camouflage, a knot of dark matter behaving in ways our models can't predict, or evidence of physics beyond Einstein's equations, one thing's certain: this floating ring doesn't just challenge our understanding of gravity. It rewrites the rulebook on how galaxies live, die, and sometimes hover in defiance of all expectation. Every star in its loop is a sentinel guarding secrets about the universe's hidden architecture, proving that sometimes the most profound mysteries aren't just in the voids between galaxies, they're the voids within them. From phantom rings that glow without a source to galaxies spinning faster than physics allows, these 50 cosmic oddities prove the universe loves breaking its own rules. Just when we think we've figured out the recipe for a galaxy, ring-shaped enigmas show up with ingredients we've never seen. Missing cores that defy gravity's grip, backward-spinning stellar hoops that laugh in the face of angular momentum, and even diamond-encrusted hearts pulsing like celestial metronomes. Each anomaly is more than just a cosmic curiosity, it's a crack in our understanding, a glimpse into realms where dark matter tangos with visible stars, where time itself warps around ancient rings, and where entire galaxies vanish without leaving stardust behind. What's truly humbling isn't just the strangeness, it's the consistency of the surprises. Whether it's the singing galaxy broadcasting radio symphonies or the impossible alignment of quasars threading through a ring like beads on a string, these phenomena whisper a recurring truth: the universe operates on scales we're only beginning to measure. Some mysteries, like the self-healing ring stitching itself back together, hint at forces beyond gravity's textbook rules. Others, like the quantum rings where stars behave like subatomic particles, blur the line between the cosmic and the microscopic. Even the frozen galaxies' stellar graveyards where time stands still challenge our assumptions about how things live and die in the void. So what do these cosmic rebels teach us? For starters, they're proof that curiosity is our most powerful telescope. Every time we point our instruments at these ringed wonders, they hand us new questions wrapped in dazzling light. But more than that, they remind us that the universe isn't just stranger than we imagine, it's stranger than we can imagine. And that's the real magic. The moment we think we've mapped the edges of reality, a galaxy like the floating ring drifts into view, spinning around nothingness, daring us to rethink everything. Now it's your turn. Which of these cosmic rule breakers left you staring at the screen in awe? Was it the galaxy older than time itself, the black hole with its impossible shadow, or the way twin rings spin in perfect opposition like celestial ballet dancers? Drop your favorite strangeness in the comments, and who knows, maybe the next time we gaze at the night sky, we'll spot another ringed rebel writing its own rules somewhere in the dark. After all, the universe isn't done surprising us, not even close.